Share. Yes. Can anyone confirm that you're able to see? You're able to see my screen?
Yes.
Okay. So before start Kubernetes, first we need to understand what is containerization. Before entering into containerization, we should know what is a VM and how the data center created based on physical servers 15 years before, 20 years before, like that. So if you see, initially in IT sectors, they have used physical servers. You may hear that huge amount of data center we need for each and every company. Say, for example, ICICI Bank, if they want to create their own IT infrastructure and resources, they should keep their data center. In that data center, too many physical servers will be there. Okay, so there you are using physical servers for each and every applications. So normally, how the physical servers will be look like in this is hardware will be separated in the sense each and every physical server separate hardware will be there. So on top of that hardware, you need to install operating system. On top of that operating system, you need to install your applications. Actually, here I have mentioned here 3 applications, but when they are using huge amount of or very high speed or reliable network if they want, then they have to create one application per server. So what happened here? Many problems may occur. Sometime hardware failure, sometime operating failure, and sometime application side issues. Okay. Apart from this, the cost is too high. Why? Because if you want to create a setup, you need DNS server, you need DHCP server, you need application server, and you need front end application, back end database servers. So for all these, you have to create one separate physical servers, and you have to maintain. Okay, and power all the aspects. If you see cost wise, it is too high. So then they slowly move. IT sector slowly move towards virtual machines. So what is this virtual machines? On top of this hardware, what we used to do, so here operating system we install. Otherwise, directly hypervisor also they may install. Thick client, thin client is there. So to understand, on top of hardware, there will be a hypervisor. On top of hardware operating system, on top of operating system hypervisor will be there, and most of the cases directly they will use thick client. Okay, on top of hypervisor they will create virtual machines. See, this name is physical and here virtual. What is mean by virtual? Physically it is only one, but you can create multiple operating systems. Okay, multiple servers, not operating system, multiple servers you can create. So each and every server isolated. So this server and this server in between, they cannot communicate unless you provide a network access or user authentication access. They cannot provide both the servers in between these two. Okay. So what normally these virtual machines will do, this hypervisor, what normally it will do in the sense, it will share the hardware resources of all these virtual machines. Okay. So here one server, one hardware, but here multiple servers, one hardware they use. Okay. For that very familiar VMware, you know that. So by using VMware, what you can do, by keeping hardware, you can create multiple VMs on top of that hypervisor. Okay. After that, what happened? Now we are moving towards containerization. What is the difference between containerization and virtual machine? As I said, in the virtual machine, on top of hardware, there will be, right? On top of hypervisor, you can install multiple OS. But here in containerization, on top of hardware, you will have one OS kernel, OS in the sense operating system. So on top of operating system, you may have the container engine. So what this container engine will do in the sense, like how your hypervisor communicate your virtual machines towards all the hardware. Whenever these servers need hardware requirement or input output requirement, all these will be fulfilled by hypervisor, correct? Like that, here container engine will be fulfill all the needs of these different containers. So another major difference is virtual machine shares the hardware amongst all the virtual machines, correct? But here in containerization, it will not only share hardware, also it will share your operating system, that is software. Okay, not only it is sharing hardware, it will share software also. So when it is sharing software, here there is a high chances to compromise security, correct? So that is why that what they have done. So see here, I have one container here, another container here. Both the containers I could run applications differently, like how I run from virtual machines, correct? One is for web, one is for database. Like that I can execute, I can run. But here what happening, the library files on top of container, only the minimal library files which is used for this application. For example, if I use Nginx server, this one is Nginx server, or your any database servers. Okay, for that particular server, whatever library files need, those library files only they will keep here. Then other all the common library files they will take from OS in the sense operating system. Okay, operating system kernel. So in normal, we could say virtual machines shares hardware amongst all the virtual machines, but here in containers, it will share along with hardware, software also it will share. Okay. Now basically OS kernel. So on top of this, we could install multiple applications we could deploy. Many people will say OS will be here. On top of it, there will be no OS and only library files and applications. No, OS also will be there here, because on top of OS only we are going to deploy our application. But that OS is very minimal library files and bin files will have. Okay, so wherever security will not breach, those files will keep here inside the kernel or inside operating system. And if I share this library file, my security will breach. In that condition, they will not keep here. They will keep all the files here. So on top of container, OS also will be there, but that is very minimal library and bin files it will keep. Okay. So due to that, what is the advantage of this? The advantage of this is you can run in single operating system. On top of single operating system, you can run multiple applications you can run, and this is very lightweight. For example, here if you want to install one web server, for Nginx server, if you want to install, you need around 3 to 4 GB, 5 GB total server total storage it will utilize, and you need RAM, you need hardware, all those things, correct? Here around 300 MB, 400 MB, max to max 800 MB. That is enough to execute. That is enough to implement your web. Okay, web servers. So we'll discuss more about this going forward. Okay, so what is Docker now? Many people are thinking that Docker is not Docker only container. No, Docker is one of the container. Container, we have many containers. Like in operating system, we have many operating system. Correct? Windows, we have Mac, we have different operating system. Even though in the Windows and Linux, if you see Red Hat, we have, and Ubuntu, we have different operating system we have, correct? Like that, Docker is one of the container. We have some other containers as well. Okay, but why Docker is more familiar in the sense? Because this is open source, and second, if you see, it portability, reproducibility, and efficiency will be more in Docker with compared to other containers. Okay. Next, so this is what the Docker architecture. So in Docker architecture, these three things are important: client, Docker host, and registry. So client is nothing but wherever you are type. For example, here I'm typing something, uptime, correct? So I'm typing here I'm getting output. This space is client. Okay? Client space is nothing. It will allow you to execute some command, okay, and it will show you the output as well. See here, I execute the command and I'm able to see output as well. So that is the client, okay. To execute this command, basic thing is you have to install Docker container engine on top of your server, okay. I have not first server, so we will install and we will practice how Docker is working, okay. And Docker host, if you see the Docker host will communicate with all the other pods via Docker API, that is Docker daemon, okay. So whatever command you are giving, those command directly it will come to Docker engine, okay. Docker engine directly, the Docker engine, Docker daemon, okay. So it will come to Docker daemon. So Docker daemon will decide where your request to send to the next level, okay. Say for example, if you want to pull any server, sorry, any image, okay. So you are giving Docker pull image. So when you are giving Docker pull image, so what your Docker daemon will check whether that image is already available locally or not. It will check. If it is not available, then it will send your request to the registry and it will download it. Same like if you want to run, then it will come and check whether it is available here or not. If it is not there, then it will tell you, boss, this image is not available. Okay. Before going to the next topic, we will discuss about image. What is this image? Image is nothing but, see, here you are creating one container, correct? This container running application, okay? So this container you can take a backup. That is one of the advantage of Docker. So previously what happened when I was started working as a Linux administrator, in our data center, if one of the Linux server or Windows server goes down, it coming kernel panic or blue screen error, something if it is coming in the sense, we engineer have to sit and try to fix that server as soon as possible. For that P1, P2, P3 and all they will create, we have to run behind it, okay. So now there is not that is no, there is no possible to take backup whole server along with your application. But here what you can do in the containerization, you can take the backup of complete container and you convert that container as an image and you can store into centralized location. See, you may heard who was working on virtual machines, especially on data center and all. We have golden image. What is that golden image? First, they will install operating system on any one server. Okay. Then they will install all the prerequisite software. So whatever they want, they will install all the prerequisite software and all the setups they will do. Okay. Mount file systems and /etc, FS tab entries and blah, blah, blah. All that is what we are saying commissioning, correct? That is part of commissioning. So whatever they want, they will do all the basic setups and they will take that server as a backup and that backup will convert as a golden image. So finally they will give you, your manager will give, okay, go ahead and we have golden image, go and install on 100 servers, go and install on 10 servers. So what you will do, by keeping that golden image, you will go and you will start installing operating system on your servers. So what happened when you install that golden image, whatever you did, the basic requirements, whatever you did setups, correct? All those setups you no need to do again. Why? Because already it will be come along with that golden image, because you have taken the backup of already configured server, complete server. Okay. So same like here, whatever container is running here, that container we are taking backup. So whenever this container goes down, you simply what you can do, you can take that backup and you run that container. Hardly it will take 1 minute. 1 minute is more. Sometime it will take 30 seconds. So within 30 seconds, your server will come up, your application will come up. But before containerization, what is the case? You have to call the storage team, network team, operating system team all will join together in a call, and they will discuss where is the issue, what happened, what we did, and whether patching happened, whether application side patching happened, or any changes happen. All those things we need to discuss. In the discussion itself, it will go 2 hours. Okay, but
I
now
have one question. I have one question over here. So when you take the container backup, which is fine for any issue, it will fine. But we can run as a replica set, right? So any one container goes wrong, we can have a remaining container, right, to serve the request.
yes, we can do that. You can do that. What happened if your complete replica set also goes down? Somewhere you need to download that your updated image here from here, correct?
Yeah.
So that is
Okay.
the one. But when we discuss about replica set, all those things, but for basic understanding, we'll go in this way so that easily we could understand what is the advantage of containers.
Okay.
Okay, so that we could take backup and we could store here. Okay, so in this registry, already this Docker company or team, the organizations, they created many images like this. I told golden image, correct? So that those types of golden image already they created. If you want for Nginx, yes, we have Nginx. What is Nginx image will do? Basically, there will be Ubuntu or some operating system. It will be there. On top of it, they will configure Nginx and all the basic requirements of Nginx applications. They will configure and they will take a backup and they kept here as an Nginx image. So whenever you are downloading this Nginx image, your application is ready. You no need to do any special configuration. Okay. So that is what the image here. So in Docker, we can via Docker daemon, we can create our Docker container by using images. For that, first we have to download the image from the registry. After that, we can create a container. After container created, this container is something like if you have the firecrackers there, correct? Rockets in someone's birthday, you can see that 50 rockets will go one by one, back to back, it will go, correct? Like that, you can create multiple containers by using single image. So you have image locally. So you can, using this single image, you can create container 1, container 2, container 3, same kind of image. You can create n number of images, you can create it. Okay. And these containers also you can control whether this container you need to stop or start container or remove container or delete container, all those things you can do that. Okay. When we are doing the practical session, I hope you will understand more. Okay. So whatever I said, that is what here I have mentioned. So it will help to go through. Okay. See how it is working. That is what I said. User interact with Docker client. Docker client is nothing but wherever you install Docker and wherever Docker commands allowing you to receiving from you. That is what the Docker client. Okay. Then Docker client will send the commands to your daemon via REST API. Then after that, what happens? Based on your command, it will react.
Any questions, guys? No questions? If you have any questions, you can ask. Yeah, go ahead, Kiran. Think you have any questions?
Yeah, I'll open this Docker. Okay, so what we will do now, we will install Docker and we will start our containerization. Okay, so to install Docker, that is normal yum command, yum install -y Docker. Okay, so then we will start the container. See, yum -y Docker. We need better. We'll go to this one, what is that? Root user. Otherwise, each and every time you need to give sudo space -i. Okay. So I'm giving yum install docker.
Is that repo public?
Sorry.
Is that repo public GitHub repo? Is it open for public?
Yes, public only. But still, we have not accessing repo. Just we install a Docker engine. Okay.
Yeah.
So Docker version. So after install, if you type Docker version, so you will get this output. If you don't get this output, then your Docker is not installed properly. Okay.
So is this installing the Docker client or the complete daemon and all that?
Complete daemon actually. Okay. So here, so this complete Docker host. Okay. So
Okay.
Docker host, there itself we are using CLI. Okay, client, we are not using separate client actually. That is why this is Docker engine, and wherever it is receiving input in the same host itself, we have Docker host as well as client.
And if we have to just install the Docker client, what we have to do for that?
No, Docker client, you have Docker CLI, you can access from other servers. Okay, but most of the case they will install Docker engine and Docker this one here itself. Okay, but you have separately, you can, if you want, you can access.
I think Docker
Why?
desktop.
Because why? Yeah, Docker desktop is nothing but that is GUI. Okay, graphical user interface. In graphical user interface, also what you can do, you can install Docker. Why? Because many people they are not good at commands, correct? So during that time, they may go with the Docker desktop, but this GUI will not accept in IT sector. That is why we don't recommend that. They will not allow you to even download a Docker desktop on your laptop itself. They will not allow you. So
Yeah,
you have
right.
to do in this way only. Okay. So we have installed Docker. Next, what we need to do, we have to start Docker. Then we will enable it. Enable in the sense, the next reboot, your Docker engine will be automatically started. Okay. If you don't do this, what will happen after reboot? Again, you need to start. That is basic Linux commands. Okay. So system CTL.
one question here. I have one dot. Okay. You said that most of the customer that Docker for desktop is not allowed. Okay. But what I am trying to say is a real use case. Okay. If you talk about most of the developers, like application developers, right? They develop the code, right? And after develop the code, they need to build a image, right? So they have a Docker file and then they used to build the image, and they after building image they used to do local testing, and then they used to put in that registry, right? Either Azure ACR or whatever, a Docker registry, that private registry where you can do that enterprise, some different registry, but okay. So
Yes.
so for those developers, right? So when you are building an image, Docker for desktop has to be installed in their system, right? Then only you can build the image. Am I correct?
Okay. Actually, what he asked, Docker host is sorry, Docker desktop. See, Docker desktop and Docker host are different. Different in the sense, Docker desktop one option we have, like how we are see. I have Docker desktop. Okay, good. I'll open it. But if I open it, it will start eating my this one RAM. So this is what a Docker desktop. This is front end tool. Whatever you are doing in this one commands, you can do via GUI.
Yeah.
But Docker host is nothing but here is host now. So this is what. See here, this is the desktop. You can create your Docker here in GUI mode. This is not recommended in IT sector.
Okay.
Okay. But if I open it, it will take huge RAM. Let me close it. Okay. not open. Okay, good. Okay, so basically, it the component.
Actually, your voice is breaking. Can you check?
Your voice is breaking.
No, I can't hear him now completely. Ravi?
Yeah, he is fixing that.
Okay, but if he's saying something, we are not able to hear.
Yeah. So can you hear me?
Yeah, we can hear you.
Okay, he is fixing that mic. It is
Okay.
moved on.
Hello,
Yeah, now we can hear you.
1 minute. I don't know. Okay, so if you see here, okay, if you see
Again,
here,
your voice is breaking in
Please,
between.
now
please
also
repeat.
breaking.
For past 5 minutes, we didn't hear anything.
Oh my God. Okay, no problem. So here, see whatever we install Docker image here, correct? So after install Docker image, we need to start our services. And here, what I did, I just I'm checking whether the service is running or not. So after installing Docker, so Ravi is asking that what is the uses of Docker desktop, correct? Docker desktop is nothing but that is GUI. By using that, you can do in a GUI mode, okay? But that is not recommended in company. But Docker host is a base component for Docker engine, okay? So without Docker hub, Docker host, we cannot do anything. What am I-
Again, could not hear you.
Okay.
No, it is fine.
1 minute. Uh,
Actually, when you are switching between the tabs, it will be breaking.
wait 1 minute. Oh, I'm not switch. Okay.
There is some disturbance in your voice actually.
Okay. Now how it is?
Now it's
Okay.
But the screen No, we
No,
don't hear you if you're speaking.
If you are speaking, we cannot hear you.
I think he is also not able to hear us. His headset is not at all working.
Can you hear?
So Ravi, are you able to hear me?
Yeah, no, I can hear you.
We'll go with this one. So now the problem will not come, I hope. Okay. So now what I did, Docker, I have started. It is running fine. And now what we'll do, we will pull image from Docker registry. Okay. So for that command is Docker pull any one image. So how can I know what images are there? You can directly go there and you can check. See, Docker Hub we have. Go to Docker Hub. Docker Hub is nothing but it will store all your images. Okay, even though it can store we can store our own image as well, but by default it will be stored the Docker organization itself. As I said, the golden image, right? You whenever image Docker image we are speaking, you think that that is your golden image. Okay, so just I'm coming here, I'm checking some images, for example Nginx. Okay, Nginx image I want to deploy application, Nginx application. So just I'm searching with Nginx. If you search with Nginx, here see here one batch is there, correct? Green color batch. This batch is nothing but official in the sense it is given from Docker Hub. The other batches and all there, correct? This is created by someone else, like you and me. Some people's they created and they given, like here they have mentioned. Okay, these and all verified by Dockers. Okay, okay, and sponsor OSS in the sense someone else they will start. See the result. If you see 10,000 result, 10,000 images are there. Okay, in that which one we can take? We can take top one. Okay, so Nginx. So if you click here, so you will have Nginx image. In that, if you go to tags, here all the versions. For example, previous version they will some tag. So these and all previous image. This is the latest image. If you Docker pull Nginx in the sense, it will download you latest image. No, I want one image before in the sense. Then you have to add a tag here. Docker pull Nginx : after that you have to give this tag 65C if you want this particular image. Okay, but here what we will do, we will take our data. So what I do, Nginx. Okay, if I Docker pull Nginx, what it will do in the sense, directly my laptop, my server. Okay, this is EC2 instance I created in AWS. So this EC2 instance, because it has already internet access. So what it will do, when I type Docker, suddenly what our Docker engine will do, as I said, it will go and check whether that image is locally available or not inside your server itself. If it is not available inside your Docker host, if it is not available, what it will do, automatically it will go to registry and it will download. To download, we no need any this one, what is that, credentials we don't want. Okay, but some images are there. For example, if I maintain my repository and I make that repository as private in the sense, during the time it will ask credentials. But whatever the images which is uploaded by Docker Hub, For that, don't want any credentials. Directly what it will do, it will first, whenever you give, see here, what I did, Docker pull, and I gave one image name, correct? Whatever image name you give, directly it will go and check whether that image is available locally or not. If that is not available, directly it will go to registry and it will try to download from registry. Okay, that is what happened here now. So there was no image because this is my new server. So there was no image. What just now I installed the Docker as well. So there was no image. So directly what it does, it directly go to the Docker hub and it's downloaded the Nginx image. How can I check whether my image is downloaded successfully or not? Even though it is showing here full completed like that, but how can I verify? So for that, Docker images, if you give, so it will show you. See here, this Nginx tag I said, correct? So this tag by default, if you don't give any tag, okay. For example, I want to give any tag number here. You cannot give randomly. You have to check what is the tag number. If you give that tag number, then it will try to download that particular Docker image, that particular Nginx image. But I have not given anything. So by default, what it will take Nginx latest, like that it will check. See here, it is mentioned downloaded newer images of Nginx latest. Okay, so it now this image is present in my my local system. It is available. Next time when I go for Docker pull image, it don't want to go, and again it will go. It will not go and it will not download. See here, it is already telling image is up to date Nginx. It is up to date already. It is available. That is what it will say. Okay, this is how we can pull any image. Image is nothing but your golden image. Okay, so next what we'll do, we'll run a container. See, to run a container, I have given all the screenshot and documents so that it will be easy to you. Okay, so to run a container, we have a command called docker run -d -name, and this name, whatever you can do. Okay, whatever the name you can give. After that, you have to expose the Nginx. Why? Because Nginx is a web application. So here, if you want to access this application, you have to expose the ports. So here, two ports are there: 8080 for my server and 80 for Nginx side. Okay, so Nginx side, inside the Nginx container, it will be 80 port, and from my for my server 8080. This port mapping automatically will happen when you give -p 8080 and 80. Okay, instead of 8080, you can give any port whatever you want. Okay, but for Nginx or web applications, normally we will use 8080. Okay, we'll try to run the Docker container and we'll see whether our Docker image is running perfectly or not. Okay, Docker run -d the name whatever you can give. So I'll give my Docker. Okay, after that I could give -p where I need to expose. So 8080, and this 80 is Nginx end. From Nginx end, use Nginx container and use 80. My laptop, this particular here in the console, correct? Here you use 80. That is what I'm telling. Okay. So finally, I have to give the image name is Nginx. Okay. And any tag, then you have to give that tag along with this. But here we don't have any tag. That is letter set by default. So directly we are giving Nginx. Okay. So when I give Nginx, what will happen?
We can't hear you again. Hello. Hello.
We can't hear you. Can you hear me?
Yeah. I'm able to hear you.
Okay, now we can hear you.
Okay. So what happening here? So when we give a Docker run -d.
Nginx spelling is
There's a typo in Nginx
Thank you.
image name.
Nginx. Next. Okay. Here Docker container is running. Okay. So what happening here now? Docker container started. How I can say that Docker container started? By seeing Docker PS command. So Docker PS command will give you the information about what are the containers are running. So if just you download the image, it will not show you. Whenever your container is started, then only it will show you. So what happened? So okay, if I change it, not okay. Let's see. You are able to hear me, right? Correct? Okay. So whenever we are downloading Docker image, the container will start it. Okay. Whenever the container start, during that time only PS command will work, will show only these containers. Not if you keep only images, it will not show you. You have to start the container from that particular image. Okay. So now my Docker is started. Okay. Now my container is started. I will try to access this port, and I will show you. So curl what is the type address? Okay, directly we can use localhost itself instead of using IP-DT. Here we could use this IP address. So loopback address itself we'll use. Okay, we have localhost 8080 we did, correct?
Yeah,
Okay.
I have a question here.
Yeah.
Yeah, so Docker pull, you have pulled the image from the registry.
Registry.
So it gets stored in the images. So next time when you want to install the Nginx in on same using, I mean, same container, I mean different container, you have to use different port.
Yes, very good. So while
But you don't need to pull the image again because it already exists in the images, but you just need to run with a different port, the
yes,
same Nginx to install the same application.
correct. So that also I will try now. See here, I'm going to use different port here. Okay. I'll create, already I have a Docker, correct? My Docker, something like that, one. So I will do my Docker one. So what happened? It will create uh, one more container. So now one same Docker Nginx, two applications I'm running. Both are the Nginx application only. One Nginx application I exposed on 8080. One more I exposed on 8081. Okay. If I go and check localhost 8081, so what will happen? It will give me this container, my Docker one container output. Okay. If you give normally 8080, then it will give my Docker output. Okay, so not that particular my Docker application will be executed. In the sense, it will try to take these informations, this Nginx information from this Docker. Like that, you can create n number of containers here. That again, you need some RAM and CPU, the storage, all the resources dependence also there. But as much as possible, you can create it. The first time only you need to download image from registry. Once you downloaded, what you can do, you can start your Docker. Multiple containers you can create. That is what I gave you one example. Like in a birthday and all, there will be rocket fireworks will be there. So what happened, in one box there will be hundreds or 50 20 rockets will be there. So one by one it will release. Like that, you can keep one image, you can install, you can create multiple containers. Okay, next what we'll do, so we have exposed we have exposed, and we checked here as well. Let me check whether I'm able to see this Nginx on my browser or not. See, for that, as I said, I'm using EC2 instance, correct? This EC2 instance, if you go here, mine is EC2 instance. Okay. Okay, so here this jump host leave it, that is my old this one. So this one is mine. Okay, test 1.1. Okay, this is what mine. So I want this public IP. Let me check. Okay, so here I have my public IP. Okay, I copy this public IP. I copy this public IP. I'm going here. I paste my public IP, colon. If you type 8080, okay, it should show here. It is not coming because we have to allow traffic here. In EC2 instance, we have to allow traffic here. So go to security. One minute. Go to security. The stuff is running. Huh? Because that will take my. Okay, so go to security. Actually, this is block. This is one of this one security features in AWS. Okay, if you do locally, if you have any public IP address, then you don't need to do all those things. But this is good. So even though if you go for AWS and Google Cloud, wherever you go, there will be security group. In that security group, by default, they will be blocked all your all your traffic which is coming from outside. Okay, you have to do it manually. You have to allow it manually. Okay, but in your office those will be taken care by most probably a networking team will be there, but you have to allow in your cluster end, you have to allow those traffic. Okay, so what I'm going to do, I'm going to edit inbound rule. I'm going to allow traffic from outside. So add rule, here all traffic. Okay, but in your interviews or in your office, you don't say that we allow all the traffic. Okay, you tell them that whatever the subnet we need, only for that only we will allow. Okay, so I'm allowing all the CIDRs. So save. Okay, now what I'm going to do, I'm going to go and hit again. See, now I'm able to see Nginx. Okay, so the question that when we have two different containers, how it will work. So one container we are able to see 80, and another we will see 81. So when you give 81, it will give you same Nginx. Okay, now we will what we will do for differentiate, to differentiate, what we will do, we log in into any one of the Nginx and we change, we log in into any one of the pod, we log in into any one of the container and change this message so that we can come to know whether my Nginx is working correctly, giving output or not. Okay, so what I will do, I will go two containers we have, correct? So I will go one of the container. I will log in into one of the container. So how can we log in into the container? Docker exec -it container /bin. These are the commands.
No, it didn't copy the container ID.
It's the IP, I guess.
Sorry. So it will take container ID. See, now I'm inside the container. Okay, so now if I check Nginx version, so -version, I think nginx version. No. Okay, no problem. So for Nginx, what is the default location to store your this one file? the configuration file in the sense. So that will be under user. Let me check that. Okay. CD, yes sir. Local. PC. Just I'm looking that Nginx by default configuration location. Okay, this one. USR share Nginx HTML. So this is the place where your Nginx configuration will be available. Okay. So what I'm going to do, I'm going to this path. So I'm checking. So here index.html, correct? So what is inside index.html? Only these content will reflect on your screen. Okay? So normally what application team will do, this is their web page, correct? So this web page, they will decorate it. Decorate in the sense whatever informations, whatever things they want to add, they will add all the things here. So if you take any Facebook, what normally it will do, blue color will come background, Facebook will come username and password. Whenever you're giving the username and password back, and it will go and check, all those things will happen, correct? So the web developer will develop this web page. Okay. So here by default, it is showing this this content. So we will change this content and we will check whether this our updated content is showing or not. Okay. So here, if you say cat engine index.html, index.html, see, this is the content. See, welcome to Nginx, and after that for online document, blah blah, all those things are there. No, this is what it will show you on the web page. This is the HTML code. What we will do, we will remove all those things and we will put our short HTML code. There is that. Okay, I'll take HTML code from here. Okay, I'll take this HTML code. Okay, this is normally one simple HTML code. Okay, I'll update here. So echo. Now I'll use single redirection. Why? Because it will erase all the old content, previous content, and it should update. So index.html. Now if I cat index.html, nothing is there. Only it should work with Docker container. Only this is there. Correct? Now if I go and hit my application, my web page, this content should come here. Okay, I'll hit. See, for which one? For 8081 container. Now I'll go with the 8080 container. So it is giving Nginx only. Why? Because we have changed the output for only 8081 container. So do you have any question here? Okay. So far what we have done, we installed Docker.
One question here.
Yeah.
So if you want to replicate the things you have done right now, let's say there were multiple containers of count 10, and we want to replicate the changes what you did right now for 5 containers out of 10. So can we do that simultaneously, or do we need to execute this whole procedure for each container separately?
Very good question. So if he's telling that if we want multiple containers, like just now I created only 2 containers, correct? What else if I want 10 containers? So yes, you have to do it manually. So this is one of the disadvantage of containers, correct? So each and every time, whenever you are executing the container, what will happen? Sometimes it is goes down also, we don't know, until and unless user telling that, hey, my website is not working. Like just now, how you said my voice is not working, correct? So this, whenever when it impact to the customer, then only they will come and say, then only we'll go and check that. Even though we have some monitoring, all those things we have, what happened, customer will impact. Even though If it is 5 minutes or 10 minutes, customers will impact, right? We can create multiple containers here by using single image, but that is not good idea. That is not suitable to our IT infrastructure. So for that only, we have Kubernetes. Okay, that in upcoming sessions we will learn more about this. Okay, these all the drawbacks will be fulfilled by Kubernetes. Okay, now what we can do, we have created containers, we run containers, and we check whether we are able to we expose the container on port 8080 and 8081, and we check whether we are able to see the output in our web browser or not. Correct? Yes, it is working fine. Now I want to take this container as backup. Okay, I want to take this container as backup and push this container into my
Your image, the screen is not refer. What is changing? It's stuck on that terminal itself.
Is it? I'm on black color. This one terminal.
Terminal. Acha, okay.
Yeah. I'm speaking. I'm not doing anything.
Okay. My bad.
So just yeah, no problem. I'll go through all these things what we have done so far. Okay. Now what we can do, we will take the backup of our container. Now I change. This is how the process of creating the golden image. Correct? We create container and we did whatever changes we want. Now we need to take a backup those this running container. I have to take backup as an image. Then that image I will push it into my registry, so that whenever I want, I can download again. I can do that. Okay. How can we do that?
Create a new build for this existing container.
Yes, we can create new build, but we have a command itself. See here, we have docker commit command. Okay, by using this docker commit command, you can take a backup of your container. Okay, so how can we do that? So docker commit, after that you have to give the docker container ID, then you have to give your docker repository information. Now docker commit. Okay, docker commit. After that I have to give a container ID, which container I want to take. So 80808081, there only we got output, right? Let me check once again. 8081 8081 only I did the changes. Okay, so in the docker commit I will take 8081, this one. I'll take this container is my updated container. I want to take as a backup. Okay, so docker commit, I have to give some name, right, for my container. Let me no. Okay, so I can give my repository informations. Already I have here in the docker registry. You have to create your own login and repository. You can create it. Okay, whenever you log in with your credentials, whenever you try to sign in or sign up, it will ask you the mail ID. Okay, once you give the mail ID, it will give you one separate this one docker hub. It will give you. Okay, so here you can create your own registries. Okay, own registry, or inside the registry you can create your own repository. Okay, so that you can allow your container with someone else. So today I have created, correct? Tomorrow if you go and you give my credential, my registry information, so that you will get those information. See those images. This is my registry. This is my repositories. I have two repositories currently. One is dev pipeline is my username, and here is Nginx is my repository name. Okay, here I have two repositories. One is Nginx, another one is HTTPD. Now what I'm going to do, I'm going to create a new repository and I will push my image here. Okay.
So one question here,
Yes.
before pushing to your repository, how your server will come to know that this is my username and password? So first you need to do the Docker login in the server.
Correct. That is what I'm telling. I'm coming to say. Okay. So when I decide, first we have to take a backup. Okay. I have not to go to push my image. First I have to create my image locally. After that I'm going to push. Okay. First I'm going to create my image locally. So what is my username? Dev pipeline. This is my dev pipeline. This is my username, and what is the what repository I want. So repository I will give
Spelling mistake.
And there's a typo mistake.
Okay. Dev pipeline. So what is that? What is the repository? Already I have Nginx and HTTPD, two repositories I have. Now what I'm going to do? I'm going to create one repository name called Ravi. Okay. Here, if you want to give any tag, you can give tag as well. But if you don't want, no problem. But I will give tag. Okay. So what it will do? It will create inside my pipeline, inside the Docker Hub. It will create one repository called Ravi, and it will tag this v1. But when that happen, when we push, but we are not pushed here. Just we are making the golden image. That's it. We have not pushed yet, so it will not check any credentials right now, because we are just taking the backup or converting or running container into golden image. See what happened now? Our golden image has been created. So how can we check Docker images? If you give Docker images, then you can see here dev pipeline /Ravi. Tag number is v1. Okay, so 8 seconds ago 192 MB. Okay, size is 192 MB. So now it is created. I have two images now. Before it was only one images. Now I have two images. These images I created from my running container. Okay. Now I'm planning to push this image into my registry. Okay. So for that, Docker push. Okay. First I'll show you push. It will give you some error that you have to log in. Later I will show you how to log in your credentials. Okay. So what is my repos? This one name colon. Okay. So what I'm going to do is Docker push. See what it is telling. Request access to the resource is denied. Why? Because we have not logged in the Docker itself. We have to give our credential and we have to from here. Then only push will happen. As I said, for pull, you don't need any credential. Okay, you don't need any credential to pull official this one from public repositories. If anyone keep their images inside the private repositories, definitely you need credentials. But here Nginx or whatever the images are as public, you no need any credential to pull. But to push any images to your repository, you cannot push to say someone else repository. Okay, if you want to push, then you have to get the login credentials from them. But if you want to push anything to your repository, first you have to do login. So for that, login. Okay, it will ask username. Login success. See here, I gave my username and password. Login success happened. Okay, you can create your own repository by using your email. Okay, so once you create while creating, you can select your username and password. So those password you should give here. Now what I'm coming to say, I'm going to just Docker push dev pipeline. If I give this particular image, see pushing is happening already. So it will go to my Docker registry and it will store it. So now we prepare our golden image and we store inside our repository. So whenever I want to deploy my own Nginx, so I don't want to go now Nginx. Okay, directly I can go to my repository and I can create it. See here. So now only 2 is there, correct? I will restart. See, Ravi one repository has created. If I open this, see 1 minute ago it created. It is publicly. So whoever, even tomorrow, you also can access this and you can try.
We could not hear you.
Are you able to hear me?
Yeah.
So if you click on tag, If you click on tags, so here V1, this is what we given here, correct? So V1 tag, whatever we given here, the same V1 tag it is showing there. Okay. Next, if you want to take a backup in one more image by taking V2, then one more image will create. See here, V2 also created. Now, if you want to send this V2, this also will be uploaded. Like that, what you can do, you can take a base image which is provided by them, or you can take sometime OS image. You can build whatever you want, and whether you are getting proper output in your system or not, or in your browser or not. If you are able to see, then if everything is perfect, then what you can do, you can push your images to this Docker registry. Okay, so here in office, in IT sector, they will not use this public and all. They will have some private registry. For example, if they are using Azure, in Azure they have Azure repository itself they have. Okay, and Azure registry and all they have separately, so that they will store there itself. So like how you log in with this credential, Docker Hub credential, like that in your organization, you will log in with something your ID, something your LAN ID, or something your credentials, whatever you are trying to log in with your laptop, correct? So those ID you can use it. Why? Because backend it will be connected with LDAP. Okay, they will give all the access. Okay. So anyway, but you will not use any public repository in your organizations. This is just for testing purpose. I used that too only to understand what is Docker, how it is working. Okay. So far, any doubt?
So one here, when you are taking a backup, right? So we cannot take a backup for, suppose I have a 5 image, okay? Okay, 5 containers running, different containers, okay? For different applications. We cannot take a backup in one shot for all the containers. Example, five applications running, five applications have a different container ID. Am I correct?
Yes.
So we can take a backup in one shot for all the container in one shot. Means a Docker backup on multiple container ID and username password.
No, why? Because if you see here, your name and this tag is very much important. Okay, we cannot give star. If you give star, wildcard will not work here. But you can create some programs, shell programs. You can create so that it will go and check here. Okay, how many containers are there? 3. Okay, take one by one in loop, and it will replace here, and it will keep on push.
Okay. So separated by we cannot give that program also, like you have given my name, right? So that we cannot take like a slash this, first one should be this, second container should be this, third container should be this.
Yes, you can give, you can create multiple repositories. That is your own wish. For example, I want to send this and Raj. Okay, Raj.
No. What I'm saying is, suppose we have a 5 container. So I have given Docker backup container ID. Then I have given the username of Docker Hub. Then I have given slash repository name, and then you have given the tag name. Okay, so that tag it is associated with the container ID, right? So first container ID should be V2, second container ID should be V3, something like that. We cannot give so that it will take as a loop. No.
Here, no. Why we cannot give like this?
We cannot give. Okay.
Yeah. Why? Because most probably, if you give star, no, it will take star itself.
Okay.
Okay. So now.
Hey.
Yeah.
Say for example, if we have 2 containers, one is for the database and another one is for the application.
Yeah.
So can we take? I mean, I think that's the same question that Ravi asked. Like, can we club those 2 containers code into one container image?
No, you cannot do that. See, in application level, whatever you can do, that will be if you bring both the things in one single container, that is possible. But if you have 2 different container, database one separate container and application one separate container, if you are running, then both you cannot club it.
Okay, so one container can support multiple applications.
Not one image can support multiple. From one image, you can create multiple containers. Okay. For example, web container. If you are running web container, multiple user can access and can do whatever they want. Like how you are accessing from server, correct?
Yeah.
See, now you may heard that this Hotstar, correct? See, Hotstar, what currently they are doing, no? Whenever you are whenever you are login, no, they are creating one separate container and they'll assign to you alone. So why this is because going forward we are going to learn about the scalability and auto scaling, HPA, all those things. So what happened suddenly if IPL is running during that time, what happened? Suddenly 1 crore, 2 crores, and all people will watch. And within 5 to 10 minutes, when the match is finished, it will come drastically. It will reduce to some thousands number or some 10,000s number or lakhs numbers. So whenever again when match start, no, again it will reach to 1 crore. During that time, if any problems comes, no, if it take delay or take something, if it is happening, you are not getting the broadcast is not perfect, then what you will say, you will not pay them, correct? So that is why whenever they want to create any application, they will create inside the pod that we are going to discuss in Kubernetes. But here by using one image, you can create multiple containers. You can create, but two containers you cannot club it. But one front-end container, back-end container, correct? Database container and web application container. You can make communication between these two via networking. Whenever you are see, this is Facebook front-end application. This one, okay. So whenever you are giving username and password, internally it will go. The backend you have a database container. So internally, what it can do, it will go to the database container. It will check whether this username and password is correct or not. If it is correct, then it will open the channel to you. Like that happen. Internally, they can communicate, but you cannot club it together and take backup.
Hello. So I have a question. So if I have a three-tier application like web to app to DB, so can we install it on or host it on like Docker?
Okay, you can do that, but the problem is Docker. As I said, here we have some drawbacks in Docker. So each and every time, whenever you're creating and you're doing this networking part, all these communications which you are creating, correct? Front end three-tier application if you are creating. So you're telling that three different containers will be there, correct? So in between these containers, you have to make them speak, and you have to give all the resources like storage, all those things. So this, to manage these things, it will be very difficult in Docker, but to manage these things, we are going to use Kubernetes. So many people are thinking that Kubernetes is also a container. No, Kubernetes is not a container at all. Kubernetes is nothing but it is a managing your containers. That is what you said. Three-tier application when you are creating by using these containers. So who will take care of this container? Who will make proper communication between this container, and who will scale up and scale down this container? In the sense, all these jobs will be taken care by Kubernetes. So I hope tomorrow by end this session, you can come to know how exactly this container, how exactly we are using this container to deploy our applications. But for your question, if you are using three-tier application, yes, you can do that. You can do that, but that is too difficult to manage. To manage those things, we are going to use Kubernetes. With Kubernetes, that is possible. That is currently most of the IT sectors are going on Kubernetes only, in the sense containerization only. So tomorrow by end of the session, you will get clear idea about how the application is deploying and how we can use flexibly, reliability, and security. All those things you will learn. This Docker is just for starting, just whatever we have seen here. Okay. So this Docker is just for starting.
Okay, got it.
Okay. So now we came to know how we can create all those things. Okay. Now we'll move towards Kubernetes. Let me check anything is pending from Docker container. Okay, so just now I told Docker container, we can take a backup, correct? We can take backup in the sense golden image, whatever running container, from there we can take a backup. So you can use Docker file to create your own container also. What this Docker file will do, what we did so far, we create a container, we log in inside the container, and we change some content. Okay, after changing content, we take the backup and we push it into our repository, correct? Those things you have to do manually. First you have to install Docker. After that you have to log in into the Docker. Then you have to change the code in .html file, index.html file. After that you come back. Then you take a backup by using commit, Docker commit. Then you need to push it, correct? So all these things are manual work. Those manual works will be we can do automate by using Docker file. Here I have one small simple Docker file, okay, for you, so that by using the Docker file, what we will do, we will, whatever we did so far manually, those things we are going to do automatically by using Docker file. Okay, okay. Now I'll take the same container itself. Okay, I'll take Nginx itself. Okay, so Docker images. I have Nginx. I'll take this Nginx and I'm going to change the message, whatever inside the content is there. No, previously we did manually. Now we are going to do automatically. So Docker file I create. See, Docker file will create in YAML this one. Okay. This is YAML is one of the famous machine markup language. Okay. Even though whatever we're going to play with the Kubernetes, no, during the time all we are going to use YAML only. Okay. Here just I'm using two things. What we did. Okay. What we did first, we download the Nginx, correct? Here I'm going to tell the same thing. Download from Nginx. Okay, boss. Downloading Nginx. What I need to do? Copy. What I need to copy? I have an index.html file. Okay. This file you need to copy. What is that path? See, that path we cannot remember. Why? Because that path is this one, right? The path we cannot remember. The path will be different. Not one. So 1 minute. How got disconnected? Okay, here itself I do that. So this one another way of login here. So by using directly connect his here no in AWS, by using that I already logged in here. So my visual code got exit. Let me check. Is this the one? No, that is different. Okay, I'll go here. Okay, so Docker images. Okay, so I have a Docker. I need to create a Docker file. Vi Docker file .yaml YAML or YAML. You can give what. Okay, so sudo Docker file.yml from changing the read only file. I don't know what happened. 1 minute, because in there it is. Okay. From ngInx. Okay, so copy index.html. So this one I'm going to copy to that path. Where is the to this one? VSR Nginx HTML. Inside that one more HTML will be there. Okay, index.html. Okay, so I'm going here. I'm going to give /index.html. So what I'm telling here, whatever I did manually, I'm going to do automatically. So when I run this Docker file, it will download Nginx image. Download in the sense, already we have locally, so it will not go for download from registry. Okay, it will take that Nginx image and it will copy index.html. So where this index.html will be located, that I'm going to keep in my local. In my local file, I'm going to keep this index.html. This file, it will go, this file content, it will copy here. Okay. After that, when I run this Docker file, automatically whatever content I'm giving here, those will be coming here. Okay. So I'll give. So if you see, when Docker file is here, correct, index.html should be keep in local. So that is why I'm going to create index.html via index.html. Okay. So inside the index.html, we'll copy that this one. Now we will give some different okay. So what it should work with the Docker container, correct? Something we give like this. I'll give something. It should work with the Docker file. Just I'll give some Docker file, so that we can easily come to know. Okay, this output is coming from Docker file, Docker file container. Okay. What happened? Oh, okay, it is there. So cat index.html. So this content I given. So what this my Docker file, when I run Docker file, what it will do? It will copy this content, whatever I have given here. It will copy this content and it will paste it inside this user share nginx html index.html file, which is there inside the nginx. Okay, and it will create a image. Okay, new image. First, what we need to do? We have to do build. We created nginx file, correct? YAML file. So what we need to do now? We have to first build it. Okay. So for that command, docker build. For that, docker build dot in the sense whatever available here. So which location I need to search for Docker file? Okay, this location, correct? So don't give a YAML extension. Just I will give Docker file. Docker file. Change the name. Just a Docker file. Just a Docker file. Don't give YAML. Okay. So what I'm going to do now? Build. I'm going to build a new image by using this Docker file. Okay. Docker file. Sorry. Docker build dot. Then you have to give your credentials.
Spelling mistake.
Build. Where build? Okay, build dot, and you have to give where it in which name it should be created. This is name, where not this one, but whenever we are creating, we have to create like username / your repository name. That is the good practice. Okay, dev pipeline slash, where I'm going to store. I'm going to store the same. Yeah.
What was the relevance of this dot?
See, dot,
Docker will dot.
I'll tell you. Dot is nothing but just you have to give here slash root, correct? This is what the path you have to give. Why? Because I'm telling them my Docker file is available in slash root, correct? Instead of telling that, I'm giving dot. Dot means wherever this command is running, you go and check there itself. That is this one of dot. Okay. I'm going to use Ravi. I'll give you the more explanation about the dot after executing this command. Okay. So after this Ravi, what I'm going to use some other tags just for learning purpose. I'll give dev. Okay. Just dev. You can give. Okay. We'll give version 4 better. V4 I'll give. Okay. So when I executed, so it is build Docker image. Okay. Now we will see whether Docker image is built from there or not. Docker images. Okay, when you give Docker images, see here version 4 has been created, new image has been created. Okay, now I'll tell you what is the this one of Docker. For example, Docker pwd I'll do. If I give pwd, I'm currently standing on root, correct? So if I give ls/root, what it will do, whatever available inside the root, it will show. Same if I do ls dot, that also it will show. So root is nothing but you are giving the path manually, but dot is wherever you are executing this this command, the same path you take. Both are same. Okay. Now what we did, we created image. Now we can create our container by using this, and we will check what is the output we are getting. So we are using Docker. Locally first we will test it. After it will, if everything is okay, then we will push it to our what is it? Repository. Okay. So Docker, how can we run? Docker run -d -p. Sorry, name I have to give here, correct? What name I can give? Okay, something called my Docker file I'll give. Okay, -p. What number this time you going to use? 8082, because 80808081 already used, so I'm going to use 8082 from which container. Okay. If I give Docker file, you will get confused whether Docker file or not. I'll give something called a file or my container. Okay. So from which image it should create? I'm telling that create this particular container. This is the container name. My con is container name. Okay. So create this container, expose on this port from this image. So this is the image. Okay, if I give only this, then it will get confused. But in this same name, I have 2-3 people here. Which one I should select? Correct? I have 2-3 people here. See, Ravi, 3 members are there. Which one I need to use? So there we need to use tag. So use tag V4. Okay. Okay, wait, I did something wrong. Docker FND. Image. Okay, here no, there is no image.
Hyphen name.
Correct. So hyphen name. Okay. When I give this, my container has been created. How we can check whether container is created or not? ps-a. When you give ps-a, my container is created from this particular repository, this particular image, not repository, this particular image. Now we'll go and check. First, we will check locally. Okay. So localhost :8082. Correct. See, it should work with Docker file. So this output I'm getting from this container, okay? This container created from this image we created from Docker file. Inside the Docker file, we have given this particular index.html, correct? Whatever we gave this message, that message is I'm able to see here. Let me check in browser as well via public IP. So I'm going to use 8082. See, I'm getting the output here by using Docker file. So by using Docker file, you can do the images, whatever the changes you want to do. Take one image and do the changes and take a backup, or take a image. All those things you can do automatically. You no need to do any work here. But first, whenever when they started, they will do manually only. If all are working perfect, then they will create Docker file. So whatever they did manual files, all they will put inside the Docker files. And to create the Docker file itself, we can give a 4-hour session. See, because different commands providing by Docker. For copy, what is the command? For we have used from, right? Who gave that from? Docker Hub itself telling that if you want to do, you use from. If you want to download, don't give complete command Docker pull like that. You don't give. Just you use it. Just you use it from. If you tell from, after that, if you give any name, so my Docker engine will come to know, okay, this guy is want to download this Nginx image. Same like if you copy, then my Docker engine will easily come to know that, okay, he want to copy the content of here to here. So like this, we have a number of commands. By using that, you can automate your Docker files, or you can automate your Docker to take a backup of your image, or to do changes and take a backup of your image. Okay, now we have images, but if you go and see, this image will be not available in your repository. Okay, if you go and check inside the Ravi, okay, yeah, inside Ravi we have version 1 and version 2. Version 4 will be not there. Why? In the sense, we have just create an image and we run that image locally. We have not pushed yet. That is why it will not show here. See, version 1 on version 2 only there, version 4 is not there. So what I'm going to do, same. I'm going to push, Docker push. So which image you are going to push? This is the image. One time if you log in, then for the same user, root user I logged in the root user I logged in, correct? For this user, it will allow you. So v4, we give v4. So it will push and you can check in sometime. Okay, any so far? Refreshing. Okay, v4. See here. V4 less than 1. Okay, less than 1 date is telling. Okay, the same image. See, locally I have that image, correct? If I don't have, say for example, I don't have this image, how can I delete that image? Okay, first we will we'll see how to stop this container. So Docker PS. So Docker PS command will give you all the running container, correct? If you want to stop this container, which one? The which we have created from version 4, correct? If you want to stop this container, so Docker stop, then you can give the container ID. If you give that container ID, it will stop your container. Once you stop, then if you go and do the call 8082, what it is telling? Could not connect to the server. If you go and refresh here, it will say could not connect to the server, which means your application properly down. Okay, this is what the advantage of Docker. If someone is telling that, hey, my application is not working fine, what you can do? You can come and check here. Okay, this Docker something corrupted, blah blah. Okay, do one thing. You remove this Docker container. How can we remove it? Okay, Docker RM, remove it from here, copy and paste it, remove. Okay, the Docker, this one is removed. Now we can create again. So how can we create? So same, I created. Now I'll check customer. Hey, go and check now. He is going and checking. He's able to see. But what was the condition? What was the situation before when we are using VM or physical servers? So if whenever he's telling my website is not working, then you have to raise a P1 and you have to call all the guys and all the team will join. And initially OS team will check. After that, the application team also will check, and they will find the root cause, and they have to create all those things, or they have to fix the issue. But now, if anyone tell my this one is not working, my application is not working properly, no problem. You delete it and you delete it and you do it. Okay. So again, what I'm going to do, I'm going to stop that Docker container. I'm going to remove it. Okay. Say for example, okay, that container ID given wrong, previous container ID itself, because each and every time container will be changed. Okay. So for that Docker PS, I have to open. So Docker RM, sorry, stop. First we need to do stop, give RM. Okay, no such container. Okay, I copied, because in Linux, no, if you select automatically it will do. In Mac, no, we have to give Control V. Okay, so stop. After that we can do RM. Now my container is not there. Okay, if I go and check my container is not at all there. Okay, my image is also not there. Imagine that my image is also not there. Image is also someone deleted. Okay, so how can I'll delete? How can we delete the image? RM I. You have to give RM I. RM in the sense normal RM. RM I in the sense image. I'm going to remove this image. Okay, there we given Docker ID. Here we have to give image ID. So my image also gone. Now someone is telling that no, I want that version 4 I want, and my container also gone. You don't have any Docker image. What we can do? We can go and pull the Docker image. That is why here itself they given command, or else we can come to know dev Ravi inside that what is the tag, so that we can give, or else we can copy from here. Okay, and we could paste it. So what it will do, when you copy and paste, what it will do, it will pull the image. Okay, it will pull the image first. See, now I'm going and checking Docker images is there. So version 4 is there. What I'm going to do now, I'm going to expose on the same port. That's it. Now again I'm refreshing. It is working fine. So this is the advantage of Docker registry, and this is the advantage of converting the running container or whatever the backup we are taking. That is the advantage. So in many organizations, all these containers managed by Kubernetes. In Kubernetes different case, what happened in the sense there, like how we are virtual. See, when you may hear that whenever you are using virtual machines, there you may see that some servers coming under clustering. The important servers come under clustering. What is clustering? Clustering is nothing but the same. For example, web application you have the same kind of server, 3-4 servers will be running in one single cluster. If one server goes down, another server will take care. Correct? If one server goes down, another server will take care. So that is the clustering. Same like here, we are using Kubernetes. Kubernetes we are using for clustering purpose. Mainly we are using Kubernetes for clustering. What clustering? Docker container clustering. If your virtual machine goes down, you have a virtual machine level clustering, correct? Same like here in Kubernetes we have Docker level clustering we have. Okay, so for Docker level clustering is nothing but Kubernetes. Okay, done. So far, do you have any doubt to create images?
I have a question here.
Yes, please.
Yeah, so we take the backup of the images.
Yeah.
So it is not the case we take the backup, like we keep on updating the application if there are any changes, right? So if we take the backup and after that we have done some changes to the application, how it is going to get reflected in the backups? Like backups are going to get updated
Yes.
frequently. Do we have anything like that?
Yes, we have us, but here in Docker, you have to take backup manually. But for these backups and all, we are going to use tomorrow in tomorrow's session. CI/CD pipelines we'll use, Argo CD we will use. So by using this continuous integration and continuous deployment, what will happen? No, I'm going to show you the live demo. Whenever you do changes in your index.html, okay. So here, whenever you do the changes on your index.html, if you log in and do some changes, no, suddenly it will go and it will deploy on your Kubernetes cluster. You don't want to do anything. Now, whatever we have done, no, all this will be taken care by automatically. So during the time, it will maintain versions there as well. Okay, if you feel that okay, something is wrong in my deployment or something is not working, so you can directly roll out and you can install it. Okay, these images as well, whenever you do changes, automatically you have to manually push that. Okay, for that instead of doing manually, we are going to do with automatic CI/CD pipelines. Tomorrow we are going to create by using GitHub. In GitHub Actions, we are going to create multiple stages. So what it will do, whenever you do any changes, automatically it will take backup and automatically it will push it to your registry. That we are going to see tomorrow. That will be very much interesting, because when we are doing end-to-end project, no, so during the time you'll get more idea.
Yeah, so in the case of Docker we have to do it manually, but in the case of Kubernetes, when we are implementing, we can do it for automation.
Yes, correct.
Okay.
Okay, so now we will start our Kubernetes. Actually, whatever we have seen, this is just a trial. Okay, as I said, Kubernetes is nothing but that is advanced clustering. Okay, what is the drawback of Docker? What is the drawback of Docker when we are running raw? The drawback is whenever maintaining, as someone has the 3-tier application when he's running, so what we need to do, so how it will be connecting, all those things are there, correct?
Managing the container.
Correct. So manage all those containers. To manage all those containers, it is too difficult when you are using Docker. So to overcome this issue, we have Kubernetes. So what Kubernetes will do? Kubernetes will take care of all these drawbacks of Docker. We are going to use Docker container only. There is no change on that. We are going to use same containers, but to manage those containers, we are going to use Docker.
So for that, we have a Docker Swarm, right? Docker Swarm can manage, right? When you do auto scaling, all those things.
Yes, that is part of this my upcoming session. Okay, I'll tell you. See, this is the main difference between Docker Swarm. Okay, Docker is actually open source orchestration, and Docker Swarm is, in some cases, it is very, very limited. See, for one of the key feature of containerization or orchestration, container orchestration, okay, scaling. But here we can do automatically, we can do the scaling, but here that feature is not available. Okay, like that we have some drawbacks in Docker Swarm. That is why people are started using Kubernetes, and Kubernetes is open source. Initially it is started with Google actually started. After that they gave to CNCF, okay, Cloud Native Computing Foundation. This is one of the foundation. So whenever anyone can create open source, no, they will give for the world, the sense, okay, freely you can use like that. Okay, so this is open source. Many we have drawbacks in Docker Swarm. Okay, we'll start with Docker. We'll start with Kubernetes. So as I said, Kubernetes.
One last question from my side. So is there any difference between Docker and Podman? Major difference?
Docker and Podman, no, but what I suggest, first you have to work on Docker. Why? Because Pod1 is a different community. They're taking this containerization from Docker only. And why? Because this is open source, correct? So they have taken from here and they added some more features in Docker. Okay. So for example, you have OpenShift, right? There is no difference between OpenShift and Kubernetes in architecture level. Okay. What OpenShift did, that is done by Oracle, correct? They take this open source code and they did some modify. For example, we have in mobile, if you take, we have two types of OS. One is Mac, another one is Android, correct? Android, anyone can take and add some features and they can create their own mobiles, correct? So they can add some extra features, gadget, and something like whatever they want, some different kind of applications or features they can add, they can release it in the market. Same like Podman is nothing but it's taken from here and they have done something, they may add some features and they giving to the customer, so it will make their life easier. But what I suggest, go with Docker. After you complete Docker and Kubernetes, then you go and check about Podman. That will be easy to you. Okay.
Okay, fine.
Okay. So Kubernetes, already I gave introduction about Kubernetes. Okay. This Kubernetes, many people are thinking that only we can install on cloud. We cannot do on our physical servers and all. No, that is not the case. Even though you can install this Kubernetes, even though Docker also, you can install on top of physical machine, virtual machine, or cloud machine. In the sense, cloud services. Okay. Cloud machines also normally, like I have EC2 instance, correct? Like that, you can install it on EC2 instance. Okay. You can install it on use EC2 instances. Instead of that, our cloud providers, see here, EKS, GKE, AKS. So Amazon providing Elastic Kubernetes service. So this will come under, see, three types of main things are there, correct? IaaS, PaaS, SaaS in cloud, correct? Cloud computing. So what is IaaS? Infrastructure as a code. PaaS is the platform as a code. SaaS is the software as a code. So infrastructure as a code in this, they will provide you complete servers, virtual machines. They will give whatever you want. You can do EC2 instance. Nothing they will take care. The infrastructure as a code, they will provide you everything, but platform as a code, they will take care of the OS part. If you take PaaS, no, then you no need to do any this one. So if you have PaaS, you no need to do any OS management, patching, some other things. Okay. If you take IaaS infrastructure as a code, then you have to take care of all the infrastructure, including OS patching. Okay. Third, you have, sorry. Okay, third you have infrastructure, service, software as a coding. What is software as a coding? Software as a coding is nothing but your Amazon or Google or Azure. They are giving this service as a Kubernetes as a service. What does that mean? I'll give you some more example when we are discussing about Kubernetes architecture. Okay. So next we'll go to the futures. So whatever drawbacks you could see on Docker, all those will be fulfilled by Kubernetes. So first one is auto scaling. So you also ask, right? So one pod is when it is going down, whether one container in Docker, one container is going down. What we need to do? Manually, we have to go and we have to stop and we have to remove the container and we have to create new container, correct? So that will be taken care by Kubernetes. So whenever one container goes down, Kubernetes will knows that Okay, one container is goes down. Do one thing, close it, fix, exit, and create new container. It will do automatically. Life life cycle management. So someone asked that whether we can take a continuous backup. After that, whether we could roll back, correct? So those things, it is possible using Kubernetes. And whenever you are creating anything, you can use declarative model, so that you can tell them what exactly you need. You no need to write a program like C++ or Java or blah blah. You can use declarative model, that YAML file you can write. You can tell them what I need. So Kubernetes will do that. And second, one of the advantage of Kubernetes, it will maintain your desired state. What is desired state? I'll tell you. So all these informations are, all these features are there: resilience and self-healing and persistent storage. This is persistent storage in the sense what? The permanent storage. Okay, whenever your pod goes down, even though it should connect with, it will store your important data not inside the pod. It should store outside the pod. That is what the persistent, that permanent. Okay. Next, load balancing, it will give you load balancing. That is what I said. One pod is goes down, then another pod will. This in VMware clustering, we said in the cluster VM, what it will do? Load balancing. One VM is goes down in the sense, another VM will take care. In clustering, two types of clustering was there in VM, virtual machines, not in Docker or Kubernetes. Okay, virtual machine, one is round robin, another one is active backup. What is the difference between round robin and active backup? If two servers will be there, say for example, two servers are there, both are web server only. If one server is the traffic will go to both the servers. Okay, that is round robin method. Active backup in the sense, even though if you have two servers, both the servers will not work, only one server will work at a time. When the first server is goes down, then only second server will come up. So that is active backup. Only two types of method, but here we have more flexible with compared to VMware clustering. Okay. Okay. So next, this is the difference between Kubernetes and Docker Swarm. Already we discussed. Next, we'll go to what is the, okay. As I said, for AWS, I said that I will explain you what is the SaaS, correct?
Software as a service, like that.
No, that I'll explain. Wait. Why my system is slow? I don't know. Due to the Docker created. Oh, 1 minute. I'm sorry, I don't know why my host is too slow. I was working till evening. It was fine. I'll check. Okay. So normally in your Kubernetes cluster, okay, see, this is what your cluster. Okay. Inside that cluster, you have master node, one master node you will have, and two worker nodes. So two or many. Okay. And this master node also. Okay. And this master node also, you can keep one or two, but basic setup, one master node. Okay. And multiple worker nodes.
So what, as I said, SaaS, correct? What SaaS will do in the sense, it will tell you, see, this part I will take care. Whatever you want to do, deployments and whatever you do, you can go and do it on your worker nodes. But if you go with same Kubernetes, if you go with PaaS, they will say, okay, I will give you the operating systems, whatever you want. You, whether you install your Kubernetes and you maintain your master and you maintain your all the worker nodes, correct? And third, infrastructure is there. Infrastructure, if you go and install your Kubernetes on IaaS, they will say, boss, I will not go you OS also. You have to take care of OS and you have to take care of Kubernetes master and you have to take care of Kubernetes worker. Okay. So most of the companies, they will go with SaaS. SaaS in the sense, master node.
So you are telling like it's on-prem on SaaS, difference between like that, no?
Yes, on-prem. See, on-prem in the sense, what is you? Whenever you are using directly physical servers, correct? Those will come under on-prem physical servers as well as VM. Whenever you are using cloud, that will come as a cloud. Okay, but most of the people's, most of the companies, they will go with SaaS. Very less organizations, they will go past that. Okay, I will take care of OS, I will take care of management, all those things, correct? So SaaS is nothing but here for EKS, SaaS is, for Amazon providing EKS service. EKS service is nothing but your cloud service, which is provided by Amazon. Same, if you take what is name, Azure, they will provide AKS service. Okay. For Google, they will provide GKE. Okay. Google Kubernetes engines like that. Okay. Now we are going with SaaS only. We are going to demonstrate. We have to create our cluster. Okay. Let me explain before. Let me create this. Okay. So to create this cluster, if you see here, I need three components. One is kubectl. I need. Another one is ekctl. Another one is AWS CLI. These three components I need to install Kubernetes cluster or to create Kubernetes cluster in AWS. What is these three? So if you see this, by using this AWS CLI, you can communicate with your cloud from your server. Okay, from your server. One minute. Okay, so this is your server, EC2 instance, which I, okay. From this server, you can communicate by using AWS CLI. You can communicate with AWS CO. Hi, hello, how are you, like that. Okay, so in the sense, whatever you want to do, you don't want to log in the web page of AWS console, and you don't want to do all creation, all those things. You can speak with by using AWS CLI. By using EKS cluster, you can create EKS cluster inside the AWS. Third, we need kubectl. By using this kubectl, you can manage your EKS cluster. So these three components we need. What we are going to do, we are going to install all these three components now on our operating system. So Ravi, okay, we'll do one thing. First, we'll create this. Why? Because we were planning to give a break for 8 to 8:15 or 8:20. Okay. So what I will do, first to create this itself, it will take 30 minutes. We will install all these three components, and finally we will create the EKS cluster. Then we will take a break. Why? Because meanwhile it will create and it will be ready for to move next.
Yeah. So you install all the commands and then you just run that cluster to create a cluster command, and then it will take a break. So that once will come back from the break, then the cluster will be ready.
Okay, I'll start installing these three. So first, what we need to install? We need to install Kubernetes CLI. So for that, you have to go and refer. So all these things will be available in Docker document itself. Okay. So I'm going to install on Linux. Okay. So this is Linux. Okay. See, this has been installed. kubectl
Spelling.
I think we just downloaded it and not installed it yet.
Let me check that. Yeah, kubectl we downloaded. So now we go and execute the step to download. One minute. I'll share you this as well so that you will get complete information. Okay, validate the binary. This is optional, but we will validate it. If it is coming okay, then good.
Just to type kubectl, I think it will work.
No, I will check here. If it is come okay, then good. Binary is good. Okay, after that, we'll go and install. Okay, version client we have to give to check. So to check this version, okay, kubectl has been installed successfully. First part is done. Okay, now my EC2 instance. Okay, EC2 instance in the sense it is out of my cluster. AWS is different. Sorry, EKS cluster is different. My EC2 instance is different. This is out of server. Even though someone sitting here, server in America and trying to access from here, so no problem. They can do these configurations via these ones. So next, EKS CTL. Okay. So for that, we have to, if you go this page, all these informations will be there. No problem. We'll directly take from here and we'll run it. Same whatever we did just now, correct? So all those things. So what I'm doing, I'm setting one variable for arc, another variable for platform, and after that I'm downloading this star.gz file. Okay. So after that, we will verify whether my code is perfect. Check by using this checksum. It's okay. Good. No problem in the code. So we'll untar. For untar, we are using XVF. For untar, we are using XVF. See, all these informations, I'm copying and pasting from this website provided by EKS. It is not created by me. Okay. If you go that website, all the steps they have given, we just you have to EKS management to remove. Okay. Why? Because here after installation, it's asking to remove. So it's asking confirmation. That is not bad. After that, we move some this one to /local bin, so that whenever we give EKS CTL, then it will work. Okay. So this also will check EKS CTL. See, same version. Done. EKS CTL also. Finally, we are going to create AWS CLI. So here we have one challenge. Whenever you are trying to communicate with AWS CLI, okay. First we will install AWS CLI. Then I'll tell you about the credentials. Here we need credentials. That is very much important. Okay. So what I'll do first, I will copy this. Okay. Here is my after that, unzip and sudo, both I will give in one shot. How much files? Okay. Let it unzip. Once that is done, we will create EKS cluster. Before create EKS cluster, what we need to do, we have to make a communication between AWS CLI to this AWS cloud. For that, we need two keys. One is access key. Okay, see, it's done. Sudo.aws install. Okay. Get an
Already installed, no?
No. You can run user, no problem.
You should type AWS-CLI. CLI configure. AWS CLI configure.
Yeah, that is for communicate.
AWS space -CLI.
No. Wait. This is Docker.
AWS hyphen CLI configure. CLI space configure.
Configure. No. Wait, it is showing that the script please reinstall. Why? Call unzip. Okay. 1 minute. Let me do the steps again. Unzip.
Previously, you have selected two commands to execute, and one of them is to install the AWS CLI as well.
Yeah, that is what, but it should work. Let me check. But in Linux, that should work. Even though if you give a
If you can type AWS configure also, I think it will work.
yeah, AWS space configure. Let me check. Meanwhile, I have one more this one. Let me try it and let me check what is that. What command?
No, AWS configure will work.
AWS space configure. ABCD. Okay. Sudo /AWS install. Found pre-existing AWS.
Just to type AWS space configure. It will ask you access key secret key.
It is working now. So it will ask two things. One is access key. How to create this access key? So this access key already I've created, but I'll tell you. Okay. So go to your AWS console. Okay. And go to your, click on your username profile. Okay. Here go to security credentials. And this is very important credential. You should not share with anyone. So after complete this class, immediately I will remove my this one access key. Why? Because if you share with someone, easily they can access your console from outside. Okay. So there you have to create a access key. What is this access key? This access key is nothing but you are creating the authentication to access your AWS cloud from outside. Something like you are giving your credentials, username and password. Okay. So here, come down in access key, you have to go and create access key. Then it will ask you, it will not ask you password and all. It will create one access key and it will give you. Okay. So this is what my access key. Password, it should have, let me check. So access key I given. Now it is asking secret key. This secret key you cannot take from here. Why? Because only one time it will show you. Okay. If you go inside also you cannot take. But when you are creating, during the time it will give you the access key. That access key I stored here. So I will take this. I will try this access key. Okay, I give an access key. So it is asking region. So which region? So Mumbai, correct? This one for Mumbai, you have to select AP-South-1. So AP-South-1. So it's asking format. Let it be normal format. See here, you have you have connected with AWS. cluster. Okay, you given authentication to your virtual server that you can go and play around with AWS cluster. Okay, by using commands, whatever you can do with commands. Okay, now this server, correct, this EC2 instance, inside that EC2 instance I installed AWS CLI, EKS control and the kube control or kubectl, all those things I installed. Now I'm going to do one by one. First, what I need to do by using EKS cluster, first I communication done. After that, by using EKS cluster, I'm going to create a new cluster. Okay, for that, this is a simple command. So before this feature, what you need to do now? You need to create service group, sorry, security group, and you have to create VNet. VNet in the sense here in AWS virtual network, you need to create subnet, all those things you need to create. But by using this EKS CTL, if you create via this EKS CTL, it will take care of all the necessary things from your cloud. Okay, I'll show you.
So that role also will get created, that policy that we need to create a role, right, for cluster role and worker node role.
Yes.
So that also will get created?
Yes, it will create it.
Okay.
Okay, so just I give EKS CTL, create cluster name, whatever you want, you can give. See, this is optional cluster. Just I given my app cluster. Instead of I'll give my app. Okay, just my app. Okay, which region? Because I have selected here AP South 1, so I'll give AP South 1 region. Okay, so I'll give, if it is start, yes, it is started. So now it will take around 15 to 20 minutes to complete this installation. Okay, once the installation is complete, it will be look like this. So manage cluster has been installed successfully, something blah 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 like this. Okay, so we have to wait for 15 minutes to play with our Kubernetes cluster. Before that, we'll finish our break and I'll come. What you're telling, Ravi?
Yeah. So let's take a break. Okay, and we'll meet at 8:20, 8:40. Is that fine?
Yeah, for me it's okay. Yeah. Anyone have any concern?
No.
Hey, I have a doubt.
Yes.
So we just configured AWS configure, right? So EKSCTL will in turn use the AWS account that is already configured. We don't need to separately link the EKSCTL to AWS.
EKSCTL to AWS.
No, first we install
Yeah,
one
it's a
binary.
kind of layer above AWS CLI.
Okay.
So same credential it is using to communicate with AWS.
Yes.
That's additional utility for your EKS, basically.
Correct. So when
Okay,
you give
just
the
configuring the AWS CLI is enough.
Yes, AWS CLI is enough. For EKS CTL and kubectl, you no need. Why? Because once you open the door, these two functions can use those door and they can play with these clusters and all those nodes.
Okay, yeah, got it. Thank you.
Okay, and so far, just we have started Kubernetes. Okay, Docker, whatever we have seen, that is common. That very basic Docker only I gave. Okay, whatever I explained, that is very basic Docker. Why? Because we don't want to keep more or deep into Docker. If I explain you, then you will get confused with Kubernetes. Okay, so that is basic, but that is enough for work on IT industries. That it is not something like the we gave only half of the info, not like that. Okay, that is enough to understand what is Docker. And now we started Kubernetes. Installation is part is going. Okay, so once that is done, we will start with some basic information. Okay, some theory. After that, we will directly go into how to create pods and how to deploy our containers. All those things we will see. Okay, then now 8:22. We'll come back 8:42.
Yeah.
Okay. Shall I stop sharing, Ravi?
Yeah. Okay. You can.
So we initialized cluster installation, correct? We will check what is the status. See here, the cluster installation has been completed. So you can see that if you see this message, it will create one by one. It will assign public IP. It will create private IP, public IP. Then it will create security group. Okay, so all those things it will create. Otherwise, before this, what we supposed to do, we create all those things manually. But by using this EKS CTL, it will be ready-made. See here, node group it has created. Okay, so like that it will create, and by default it will give you 2 nodes. Okay, master node, as I said, master node will be taken care by whom? EKS, Amazon. Okay, only whenever we have the deployments, during that time, whenever we have the upgrade, during that time we can take control and we could upgrade. Rest of the times, rest of the part will take care by Amazon itself. Okay, now it is installed. Actually, I will close this this one, web access. I opened here. Okay, actually now we are going to enter into Kubernetes topic. Okay, so far just we installed. Now, as I said, in Kubernetes we have 2 types of node. So here, node, server, host, all those things are same. Okay, node, server, host, all those things are same. Okay, we have 3 servers normally. So one is master, another 2 nodes we have created for as a worker node. So whatever we are deploying, our containers, whatever we are going to deploy, previously where we deployed on our EC2 instance on our server, correct? But this time, inside the server, we deployed containers with the help of Docker, correct? But this time, we are going to deploy all our containers inside these worker nodes. Okay, so before entering into this, I'll give you more explanation about worker nodes and Docker nodes. So we will see the overall infrastructure of Kubernetes. See, this is what the master node. Okay, and here we have 2 worker nodes. Okay, so in this master node, we have some components called API server, controller, scheduler, and HCD. These 4 are the major components of master node. And worker nodes, pods, that is very much important. Inside that pods only we are going to deploy our container. Okay, so pods, and we have kubelet. Then we have container runtime. That is not actually, many people are telling Docker runtime. That is not Docker runtime. If you are using Docker, then that is Docker runtime. If you are using some other technology, then those will come. Okay, so we have Rocket, something like that. So this is container runtime. Here we are going to use Docker container. Okay, so Docker container runtime and kube proxy. Kube proxy is nothing but network proxy. We'll go and check each and every components. What is the responsibility of each and every component? See, whenever developer or user, okay, we are the user from here, correct? In the server, we are the user. We are going to use this kubectl, and we are going to speak with master node as well as worker nodes, correct? So whenever user who is coming from outside, who want to interact with EKS cluster, he will come directly to API server. He cannot directly jump into pod, cannot directly jump into all those spheres. Okay. Once this is exposed, then by using IP address, you can directly hit. That is different case. But for configuration purpose, if you want to deploy anything, directly you cannot come and speak with the pod. Okay. Once your application deployed, then you exposed. After that, you can directly come and hit inside the pod by using networking. But by default, without networking, you have to speak with any components via API servers only. And second, whatever inside the master or whatever there inside the worker node, all these components will interact via API server only. For example, controller directly cannot speak with scheduler. Scheduler directly cannot speak with ETS. So whatever they need, they have to come via API server only. If controller wants to speak with scheduler, it should come via this API server, and API server will give instruction to scheduler. Okay, so directly no component will speak each other. So API server here it will work as a vital role. Okay, it will give you very important role here in API server. Okay, so 1 minute.
Yeah, here, what are we referring to API server?
Sorry?
API server, to what we are referring to? Is it a physical server or virtual server where we install the application? Or?
Okay, very good. Actually, API server, name is API server, but this API server is component of cluster. Sorry, component of master node. Master node itself, one of the server only. Master server, worker server 2. So inside that master server, you have the API server. Name is API server, but that is one of the component of master server. You no need to deploy any server, like how we create one server here, left side, correct? Like that, you no need to create any server here. All will take care of your EKS cluster, and this will take care by your master server itself. You no need to do anything manually. So API server is the one of the component of master server. Whenever developer or user want to speak with anyone, then it will, or internally whenever these components want to speak, it will go via API server. Okay.
So this component are pre-installed or we have to install manually?
Okay. This component we no need to install manually. When you install this EKS cluster, correct? All this setup already setup has been completed. It will taken care by your cluster itself. Okay. Whenever you install master server, so automatically all these components will be installed in the installation package of EKS cluster itself. You don't need to do anything manually.
So basically, when you will set up that cluster on VM, normal VM, either a physical VM or cloud VM, that time you have to install all the components, which is API server, controller, scheduler, and etcd database, key value store, and API server, which will expose the API. So whenever via kubeproxy, okay, kubeproxy is a network communications. It will expose the API to the API server, and then what he need, so that he need a controller something from the scheduler, I need from the etcd. So it will expose the API. It will get those information.
Okay, thanks, Ravi. So here we have controller. What these controllers will do in the sense, it will maintain desired state. What is the desired state? Say, for example, you are telling that inside my pod, okay, one container should run. Okay, it will keep on watch via API server only. It will keep on watch what is the current state. Okay, and inside the etcd, the desired state will be updated inside the etc, and this controller each and every time it will check what is the desired state and what is the current state. Desired state it will get from etc, and current state it will get from kubelet. So here kubelet is one of the component. This will communicate all the information, whatever command or information, whatever API server is given, or this is reflecting to any one of these component. So kubelet is the one of the main key component in worker nodes or worker server. That kubelet will give all the informations to API server. So this kubelet is responsible to give the current state of the pod. So this controller keep on monitor what is the current state and what is the desired state. Both it will compare. Okay. If it finds, say for example, this inside the pod, we are going to deploy container, correct? So if the container is down or it is corrupted or it is deleted, so what happened? The desired state will become 0. So one part, correct? So here in etc, it will be desired state equal to 1, but here it will be desired state equal to 0. So controller will take all these, compare all these two information. Suddenly it will tell to API server, boss, it is mismatching. What API server will do? Mismatching. What happened? Actually, etc telling 1, but Kubernetes telling that 0. Okay, is it? Then API server, what it will do? It will tell scheduler to schedule one more new part inside, sorry, new container. Correct? So scheduler suddenly what it will do? It will instead of installing new container, what it will do? It will delete the pod and it will create new pod and it will install the container inside the pod. That will take care by scheduler. Once that is installed, again Kubernetes will give the information. Yeah, now it is okay. Then again controller will check what is the desired state, what is the current state. So this one keep on, it will watch. Who watch? Controller will watch. Controller directly cannot comment to scheduler. As I said, it will tell to API server. Via API server only, all these things will happen. Okay. Same like here in the kubelet will give all the informations and it will get all the comment via this API server. Whatever API server is giving, it will receive and it will give it to them. Same, whatever they are telling, it will take those information and it will give it to API server. That is what the main role of kubelet. And network proxy will take care of all the networking related queries. So someone asked 3-tier architecture if I want to do, can I create 3 different containers? Yes, you can create different containers. In this pod, you can create a web container. In this pod, you can create a DB container. So the communication between these pods will be taken care by network proxy. Not only the communication between these, even though the communication between node to node. Why? Because this one is node, this one is another node. This is worker node 1, worker node 2, correct? Communication between 2 nodes or communication between the users and these nodes. Why? Because as I said, when you exposing, someone hit from outside, correct? So IP address, all those things we need, IP address, port numbers, all those things, correct? Those will take care by your network proxy. Network proxy. Okay. Any doubt? So this, okay, one more thing. This API server, whenever we are going to speak, okay, we are going to speak with API server only. We are going to speak from this outside of the server, okay? So it will directly go and hit API server, okay? So 2 types we can go and speak in UI, user interface, otherwise command line interface, GUI, correct? GUI normally, if you go open, I told, correct, OpenShift has taken the base code from Kubernetes and they added features. So here only they worked more. OpenShift, what they did, they added many features so that you can do whatever you want, whatever you are doing from command line, you can do via graphical user interface only, right? So this API, you can interact with this API via GUI or else command line interface. As I said, in our IT environment, GUI normally they will not recommend, but for OpenShift they are okay. Why? Because in OpenShift they created in that way, so it is more flexible, more security. Okay, but when you are using normal Kubernetes, normally you should use CLI only, command line interface, like how we have created here. Correct? This is the command line interface. So by using this, you can speak with them. Say for example, I want to check how many nodes we have. So for that Docker, what command we used? In front of, if you want to see anything, you have to use Docker, right? Like that. In Kubernetes, what you need to use? kubectl get nodes. Just I'm telling get nodes. So it will give you, boss, you have 2 nodes. This is the one node name. Okay. This is node name 2. Okay. And both are ready state. And what is the version of Kubernetes? Sometime in interview, they will ask what version you are using in Kubernetes to check whether you are exact experienced person or not. Okay. So this is version, and from when it is created, just now we created, correct, when we went for break. So 29 minutes it was created. If you go for GUI, here PKS, this is my AWS instance, sorry, AWS console. So Elastic Kubernetes service, when I open, I use my app, correct? The cluster name I used my app. Let me check what we used. Let it load. So if you see here, it will give you the information about my cluster, which we create via command line interface. Okay. If you don't have command line interface, what you need to do? You have to come here, create cluster, click on create cluster, then select security group, then select IAM, all those things you have to do manually. So instead of doing manually, by using SCTL, we have done. See, my -r. This is what my cluster 41 minutes ago it was started. Okay. So let me check EC2 instance, because my Kubernetes is telling that I have 2 nodes, correct? Let me check how many nodes it has created. Already I had one node called jump host. Okay. After that, I created one more node for test 21 that currently I'm connecting. This is test 21 server. Okay. This is what test 21 server. So now I'm going to check how many instances. See, totally 4 instances are there. 4 instances. So this jump host already I created long back. This test 11 week I created before starting this class. So see here, 2 nodes it is created. Who created? EKS CTL. When we create a given creating cluster command, correct? It has created 2 nodes here. Okay. If you want to see more information about this node, if you click, then you will get all the IP addresses as well. Okay. Anyway, we will see those IP address. No issues. Now, so this is the basic command, but to get the nodes. Okay. No, I want to, just now I went in GUI and I checked all this information. If I want IP address, then I have to go there in security, there I have to take. If you want to take from command line, just give -o wide, then you will get more information. See, internal IP, external IP, and what is the kernel version, and container runtime, blah, blah, all those information. Mainly, we are focusing on external IP and internal IP also, but external IP. By using this external IP, what you can do, you can access from outside, but by default, there is a restriction, you cannot access. Okay, by default, you cannot access. You have to provide a permission to access from outside. Okay. Now, see, this is what the normal setup. If you see this diagram, inside the cluster, we have nodes. Inside the nodes, we have pods. Inside the pod, we are deploying container. Inside the container, what is there? Our microservices or services. Today's example, we are going to use Nginx web application service. Okay. So by using Docker, what we did, directly on node, we install Docker and we deploy container and we check, right? But here, this structure is different. So inside the cluster, nodes will be there. Inside the node, you will have pods. Inside the pod only, you can deploy container.
So can you use multiple containers inside the pods?
Yeah, that is what I'm getting. Okay, multiple containers inside the pod, you can use it. Anyway, we are going to use, correct? We are going to use, I'll explain you, I'll give you an example. Multiple containers you can use inside the pod, but that is what I have mentioned. Typically contain 1 or more containers. Okay, but the best practice is per container, sorry, per pod, you should use single container. Why? Why? Because, say for example, this is my worker node, correct? Forget about master node. Why? Because master node will take care by EKS. We do see, we are going to work on these two, correct? So here you have, if you see inside the worker node, two pods are there. Inside the pod, I have two containers. In pod 2, I have only one container. This is on worker node 1. Worker node 2, we have inside the pod 1, we have one container and one container. So why I'm telling that you should not use two containers inside the pod inside the pod, in the sense, these both the containers, actually in Kubernetes you will not assign any IP address for the containers. IP address will assign only for pod and node, but IP address will not assign for containers. In that case, even though if you give 8080 for this container and 8081 for this container, both are same. Conflict will happen. Why? Because when we run on particular server, two containers we run 808081, correct? There, what happened? IP address are same, different ports. But here, what happened? IP address itself not there for containers. Anyway, this we will discuss more on networking part. But as of now, the container, whatever you are deploying, that container you cannot directly deploy on node, which we did by using Docker, correct? That is Docker. This is Kubernetes. Inside the Kubernetes, you cannot deploy your container directly on top of node. You should deploy your container inside the pod itself. Multi-container can be deployed inside a single pod. Yes, it is possible. But the same container we cannot deploy inside the pod. Inside the node, you can deploy. For example, pod 1 also Nginx, pod 2 also Nginx, here also Nginx, here also Nginx. So all these four are Nginx. Yes, you can do that. But inside the pod, you cannot deploy to Nginx. This can possible. One is Nginx front end, another one is database back end. That is possible. Why? Because database internally communicate with this front end, correct? From outside, no one directly hit to database. If you are opening facebook.com, you are going to interact with web application, you are going to give the username and password. Will you directly hit to database server and check whether my credential is correct or not? No. Front-end web application will be there. Facebook will take your username and password, or any banking application take your username and password. Internally it will go and check whether this guy is correct or not. If it is correct, then it will give you the reply. In that case, you can use multiple containers in a single pod, but that also most of the cases they will not use. Why? Because if one container goes down, due to some reason, one container goes down also, it will complete pod will goes down, complete pod will kill, and it will recreate. So it will impact both. So that is why normally they will not use both the containers. See, here itself I have mentioned, if pod can contain one or more container, pod can contain, but one container per pod is good, because all container inside the pods are tightly coupled. Tightly coupled in the sense there is no IPs, all are same family, no different IP address. That is the case, but we do that. Okay, next we'll go for a Kubernetes object.
Yeah, how about different web servers or application servers in one pod?
How about?
So said the possibility can be one application server and one database server. Can we go with the two application servers or two web servers?
No, inside the pod you cannot go like that, but one application container you can deploy on pod 1, another application container you can deploy on pod 2. Inside that you cannot. Why? Because two applications is two different IP address you need to access, correct? So here there is no two different IP address at all. Single IP address that will go for a pod. Pod will give that IP address to C1 or C2. Am I right?
Yeah, I mean one Nginx and one Tomcat, something like that. Because they can access with same IP address but different ports, no?
No, why? Because see, whenever pod have this one, see, you have two different kind of this one. What is that? Containers, correct? Yes, that is possible. That you can access it, no problem. One pod is Tomcat, another pod is you are telling Nginx, something like that, correct?
Yeah.
Yes, that is possible. We can do that. But normally, in single server itself, they don't want to run two application in the same server, correct? How can they run both the application in the single pod? And second, what happening here, when we are going to see advanced topic, if you deploy two different pods, containers, inside the single pods, when you are increasing your capacity during that time, it will more difficult to manage. That is the case. They are not deploying two different pods inside the two different container inside the pod. But in our practical session, we will deploy two containers and we will check. One is Tomcat, another one is Nginx, or one is Ubuntu, one is another pod, like that. We another container, different container we will install and we will see.
Basically, you can deploy Tomcat and Nginx. It will contain same IP with different ports. The problem here is, as a best practice, we don't prefer to do that because it is a networking layer. But ideally, you can do that.
Yeah.
Right?
Yeah. Correct.
Ideally, you can do that. But as per the standard best practice, any of the organization, right, they don't prefer to do that because you might have seen, right, nowadays, earlier we have one server, we can have multiple applications. We can do that. But nowadays, nobody is doing that because all are microservice running on different servers, in different containers, and it is getting deployed on the cluster. So they will not do that, but ideally you can, but as per the understanding, you can do that. But it will both the container will use same IP because the pod will get assigned to IP from the worker node. So that only port will get different. Even the port also will get same. If port is same, suppose one is Nginx 8080 and HTTPD is a different port, it is the same port. Also, it can be possible, right?
No, same port it is not possible. Different port you need to.
Okay, different port it will be possible.
Yes. Okay. Anyway, we have that in our lab session. Multiple containers we will deploy and we will try to access it. Okay. Next, we will go to the how to see whatever we have here, pod and services, many objects are there. Those objects we call it as Kubernetes object. So you can create pod. After that, we'll go to replica set, replication controller, deployments, namespace, services, volume, secret, config map. Like all these are the objects. Okay. If you want to create if you want to deploy your container inside the pod, then you have to use the object called pod. If you want to create replica set, like Ravi said, if one, for example, 5 pods I'm running, if one pod is going down, automatically Kubernetes should start that pod, correct? That was the disadvantage of directly when we are using Dockernet in a raw, easy to install. That is the disadvantage. Whenever one pod goes down, one Docker container goes down, we have to manually go and create it. But here, that will be fulfilled by replica set. So, like that, we have many objects. In these objects, we are going to work on, we are going to see each and every object in our upcoming session. Normally, I skip replication controller. Why? Because replication controller is advanced version of, replica set is advanced version of replication controller, but I'll give you the, what is the difference between these two. But first we'll go and check the work with the pod object. Okay. To create any object, you have to write a YAML file. Like how we use we write a Docker file, correct? Like that, you have to write an YAML file. You can do via command line as well, but preferable way is create a YAML file. Why? Because if you create YAML file for one time, so you can use that YAML file again and again. Okay, so this is what the one of the YAML file content to create pod. See, these four are, whenever you are creating YAML file, these four are very, very important: API version, kind, metadata, and spec. Okay, these four are very, very, very important. Without these four, your YAML file will not execute, or it will give a error, something like that. Okay, so these four components you should have inside the YAML file, or JSON file also you can write, but most people will write in YAML file. But if you are familiar on JSON, you can write it on JSON file also, no problem. Okay, so API, what is the API version? So Kubernetes API. So Kubernetes API will understand what kind of pod you are going to execute. API version will not keep on change. For example, this is version, different, not like that. It has bunch of different version 1 and version 2 like that. For networking part and all, it will use some different version. Pods and these things and all, it will use different version. Okay, but that is fixed. You no need to mug up or remember and all. Okay, directly you can go, if you want to create any part, directly you can go and open from your Kubernetes itself, Kubernetes documents itself. Okay, so this is preferring by Kubernetes. Even though if you go for Kubernetes certification examination, this Kubernetes.io. Okay, so this Kubernetes.io, this website will be accessible to you during the examination time. Okay, you can go and you can take the code, or you can read about what is pod, all those things from here. If you click here, it will give you the information about, more information about what is the pod, all those things, and it will give you the sample code as well. So if you see here, API version, kind, API version is V1, kind is pod, this is permanent. It is not something created by us, version. Okay, V1 in the sense, to create pod, you should use V1 only. Okay, metadata, after that spec. Inside the metadata, what you can declare? You can declare some labels. You can declare some labels. Say for example, LKG, UKG you have. Even though LKG, UKG, you have a class names, correct? LKG A section, LKG B section, LKG C section. What is that? That is label to identify when you have bunch of different classes. Like that, for this part, this particular label, this particular metadata, okay, it will attach as a label. Okay, sorry, no, I'm sorry, not label. This particular part, you will have the name. You can give the name. What is the name for this part? Okay, label we will see later. But this inside the metadata, even though you will declare a label inside that this one only, but name means for this particular part you are giving name. Okay, like how we have different names you can give pod 1. Okay, this is pod 1, Nginx pod. This is database pod. This is Ravi pod. Like that you can give different name for each and every pod. So this is name. Inside those information you can give under metadata, and inside the specification is actually your declaration, like how we did in Docker file, correct? So here only you are going to tell, boss, please create me container. Okay, okay, what is the name of container? My container name is Nginx. Okay, see this name, whatever here, this is pod name. Okay, this is pod name, and container name is C1 is there, correct? This C1 only we are referring here as a Nginx. Okay, that container's name. After that, which image should I use? We are going to use our image which we created. We can use public image. If you are use the Nginx, then it will go and download the image from Docker Hub automatically. As I said, for public images, you no need any credentials. But for private images, you need credentials. For example, if I stored any images inside the Ravi's folder inside my repository, when you are, I declared as a public. So no need any credentials. You directly download from wherever you want. You can directly download. If I make my repository as private, then you need credentials. Okay. After that, I'm telling port. What is this port? See, you remember when we run docker d command, docker space -d, after that hyphen name, then -p, we given two ports, correct? 8080:80. What is that second 80? That is what the container. Inside the container should expose. Container should speak with outside the world which port, with which port, correct? This container speaking someone else here somewhere, or this container speaking with C2 also. C1 container speaking with C2, correct? So via which port it is speaking? 80. That is what here we are giving container port. Okay, we'll write this one. We'll create this and we will check how our container is, how our cluster is responding. Okay, we'll create a simple pod and we will see. See, how can we create pod? You have to create YAML file. Where I need to create? Wherever you want to create. No restriction. Only you should not give any read only permission, something like that. Give execute permission and wherever you want to create it. No issues and all. Okay, now I'm going to create where I'm currently standing. I'm standing inside the root, no problem. I'll do one thing. I'll create my own directory for this one. So my app app. Okay, this is my own directory. I'll go to that my app. Okay, ls nothing is there. Okay, what I'm going to do? I'm going to create vi YAML file. What YAML file? First, something like pod1 or my pod. Okay, my pod dot YAML. Insert Control V. Here, if you want, you can give some other name. No issues. Ravi. Okay. Then here, if you want, you can give a different container name. My container. And if you want, you can use the old image, or if you want, you can use latest image. Okay, 1.14.2 is available. That may be very old, so I'll use latest image. No problem. Container, let it be. Saved it. What? I saved. Now I created. I have a YAML file. How can I execute this YAML file? When you are executing this YAML file, what exactly will happen? No, when you are executing this YAML file, you are executing from here. So this kubectl will take this YAML file. It will go and tell to the master node. It will come here, API server. First, I want to create this. API server will say, oh, is it? What do you want to create? It will read API files. Sorry, YAML file. If it's find any problem in the sense, any syntax error, something like that, it will tell you, boss, your syntax is wrong. Please correct it and come. If it is okay, then it will go and tell to the controller. Controller will schedule this via API only. And controller, and API server, what it will do what scheduler will do? It will schedule to create the pod. Then it will go, the message will go to kubelet of worker node. Then kubelet will say, okay, new pod I need to create. Okay, it will create new pod. Then what is the inside, whatever it is there, the Nginx image is there, no? All those things will directly download and it will create. And again, it will go and tell that, boss, I created. Then API server will say, okay, etcd, you keep this status. Here, we have created one pod, desired state is 1. Okay, one pod, it is available. Then here it will come. Controller also, it will keep. But as I said, whenever the discrepancy is happening, no, during that time, automatically we'll create a Kubernetes. No, by default, it will not happen. For that only we are going for replica set. That is different case. But as of now, when you are creating normal pod, as of now, if that pod goes down, your Kubernetes cluster will not create automatically. By default, it will not create. For that, we have to put one more layer called the replica set. One by one will go. But as of now, just we will deploy one pod and we will see what is the output. Okay.
So basically, can you go to the slide?
Okay.
So basically, when you deploy the application, right, with the help of myapp.yaml, any service.yaml, with your application.yaml file, okay. So when it is exposing to sending a request to API server, it send a request to scheduler, okay. And scheduler will decide on which node has enough space to create a pod first, okay. first it has to be decide which resource, because we have here pod 1, pod 2, worker node 1, worker node 2, worker node 3, it could be worker node 4, right? So that scheduler will decide which node has a proper resource to serve this request. Then it will decide and then it will expose, then all those things will get created, right?
Yeah, very good point, Ravi. Yeah, that is correct. So before scheduler, it's scheduler's responsibility to check this pod fit for which node. If both are available, it will deploy randomly. Okay. If, for example, node 1 is full, during the time it will go and go and deploy on worker node 2. Very good. Yes, scheduler will do that. Okay. Now we will go and create it. How can we create? We have a YAML file. How to create it? To create that, we have command called kubectl apply -f. -f is nothing but file. I'm going to create based on the file. Whatever in the file, you read this file and create it. So my pod .yaml. See, it is telling that pod Ravi is created. Okay. So kubectl get pods. Before what we use to get the node information, kubectl get nodes. Here kubectl get pods. Okay. When you hit kubectl get pods, it is telling that Ravi actual desired state also 1, current state also 1. Running is status is running. Okay, 80 seconds again. If you want to know the IP address, or I told correct, each and every pod will get an IP address. Okay, each and every pod will get an IP address, but each and every containers will not have any IP address. Correct. If you want to see more information about this, just you add -o void. When you're giving void, so see here, it is giving the IP address. It is giving me the IP address 192.168 dot, and it is giving some node name. Okay. Just now I told, correct? Ravi also told, whenever scheduler receive the information, YAML file or API server is telling him to schedule a pod, it will go and check which node is compatible or where exactly we could the resources are available to create it, correct? So now here we could see the information, this particular pod created on which node. Why? Because we have two nodes, correct? We have 155 node, another one is 186 node. See here, 186, 155. So this my particular pod is created on 186 node. By using this -o void, you can come to know where this pod is created. Now we have updated our this one. Shall we go and check whether my container is giving me the output or not? It is telling me your pod is running. In Docker, what we did Docker ps-a, sorry, ps, correct? If you give the ps command, you will see all the running containers, correct? Here you cannot directly see the container. Container is running on inside the pod. Pod only we can communicate. We can see the pod only. If you want, you can enter into container. That is different case. Okay. Now what we will do, by taking this IP address, we will check whether my pod is giving output on 8080. Correct? 8080 only we did, correct? See, 8080 already we have running some this one. Let me stop this container first. Stop. Sorry, Docker. Stop. Because don't confuse with Docker. Docker is chapter close. Just for understanding purpose, I told you. Then don't think that okay, inside this Docker we have to first run this container, then only this Docker will work. No, that is not it. Docker is done. I remove everything. Okay. Now I'll take this IP address. Call.
Could you clear the screen so that we can see the commands, because it's displayed at the yeah.
Okay, so let me Find it. Okay, so here get pods -o wide kubectl. Okay, so now call -o, sorry, call 168 dot it is not coming. Okay, why? Because inside the node also, inside the cluster also, what we did, we have blocked what we blocked, traffic we blocked. So let me go to this security. Security group. The security group is for complete my app cluster. Okay, so edit inbound rules. Go add this one, all traffic. As I said in your interviews, don't tell we allow all traffic. Save rules. Okay. See, where I'm executing from outside, correct? See, this is my server. This is my server. I'm trying to execute, I'm trying to speak with this worker node, correct? I'm trying to speak with this worker node. So in between, this cluster is blocking me to get any, even though we opened port, but in network level, it is not possible to communicate from outside. So what I will do, I'll take any one of the worker node, try to do call. Okay. So I'll go to any one of the worker node, or I'll directly go to this pod. Inside the pod, first I'll check whether locally it is working or not. kubectl exec -it. What is my pod name? So see, I enter into my pod. That pod name is Ravi. Here only my Nginx is deployed. Inside the pod deployed. If I tell you in the screen, in the exactly I'm standing inside this C1. In this place I'm standing. Okay, currently I logged in inside the pod. I'll check localhost. Sorry, curl localhost colon 80. See, I'm getting the output. I'm getting the output. If I want to access from outside, then I have to go to this EC2 instance. I have to take public IP. Details, networking. So I have public IP here. Okay. Okay.
You have to expose the service, right?
Yeah, service. We will see service later. Let me connect this server directly inside this server. So what I'm doing now in the sense, I'm logging inside this worker node. Before I was standing here by using command CLI, I went here, but now I directly log in into this worker node. I will check at least locally inside the server it is able to accessible or not. Okay. We will see all the concept one by one. Well, what is the IP address of the pod? This is what the IP address. See, what I'm doing from outside, you cannot access. Why? Because there is some restriction. To enable this restriction, we will use service in future. But as of now, this part not accessible from outside. But from this worker node and this worker node, internally you can access this part. Okay. Even though if you go to worker node 2 and hit this particular IP address, it will work. Okay. So this is how you can deploy a simple pod inside the cluster. Okay. So I'll tell you one more time. Why? Because I'm spending some more time here. If you understand how the pod is creating, how we are accessing, then it will be very easy for next steps. So as I said, whenever you are giving YAML file, it will come to the master node, and with the help of API server and controller, it will go and create one pod here inside the pod. Correct? So you are inside the console. You can go and check it. You can go and check how many nodes you have, how many pods you have, all those things. Even though you can enter into the pod also, you can do whatever you want inside the pod. This is how a simple pod which we could deploy inside the Kubernetes cluster. See, we deployed the pod, but still the complete networking was not happened. For your information, the complete networking was not happened properly. Why? Because not properly. Just we started, correct? So we created pod that will communicate internally. Worker node 2 actually pod was created. Pod is created, correct? So from worker node 1, you can access from worker node 1, or else you can directly log in into the container and you can do by localhost. But from outside, still it is not enabled. Okay. Now, do you understand how pod is creating inside the container? Or do you have any doubt?
Any doubt? Everyone? Yes, no.
If you want, I'll explain you again.
Yeah, go ahead. Somewhere
Okay.
saying something.
Good. So pod is done. So just we created one pod. Now we will come to the multi-container. So someone asked, correct, well, whether we can install multi-container inside the pod. Yes, that is possible. As Ravi said, that is possible. We will create it. First, I'll copy this. And I'll paste it into. And one more thing, before I'm going to this, quickly I will do one more thing. See, here, what happened? I used the Nginx, correct? Now, we will try to use our own part, which we created. Ravi version 4 something we created, correct? Okay. So, what I will do? LS. Same I'll do. This one I'll remove it. Okay. I'll create one. So, I'll create one more YAML file. My pod 1. Okay. BI my pod 1. Why? Because if I show, so you will come. You will finish the circle. Okay.
Okay. Once again here, let me explain one thing. So here, can you go back? Just you do the exit from this screen. Okay. Basically, this YAML file, right? Basically, what is happening is either in our organization, we have something, we are deploying a microservice, okay? So that YAML should be microservice, whatever the service name. Suppose the service name is login, then there will be login service.yaml file. If your application you are deploying, then application.yaml file. If you are deploying any web server, so that web server.yaml file, okay? And you can have a YAML file, and what are the steps we have, something like API version, kind, metadata, labels, container, ports, whatever things we have, right? Those, even you can add tent, you can add tags, lot of things you can add, and then you can have a YAML file. Basically, in the organization nowadays, everyone using AI. Okay, so you give all the information, they'll give you the YAML file. Okay, and then you restructure it in the proper way, validate it through the YAML validator, and then you can use that. Okay. On top of that, if you have something called multiple, okay, so you can have something called multiple YAML file. You want to, you can write a deployment file, okay. So it will write you can have one multiple service file, and you want to execute with the one. So you can have one deployment.yaml file, okay, and that he has all the steps, okay, which YAML should take all those things and it will get deployed, okay. So basically here, when you are creating a pod, basically you are deploying application, and application when it is getting deployed, it will create a pod. Inside the pod, your container is running. Inside the container, whatever the application you deploy, right? Either you deployed Nginx, you deploy any service, microservice, any service you deploy, that service would be running, okay? Any question? Make sense for everyone?
Yeah, thank you, Ravi. But what I'm thinking now, these, whatever you said, will be understood by them once we finish this, at least today's class. Why? Because just now I have created just a pod. This is not the complete this one. So, guys, so going forward, we are going to add one by one, one by one. Like if you see any car, correct? Car basically should have engines, tires, and steerings, all those things. Later they will add one feature, centralized lock, then add one more feature, AC, add one more feature, airbags. Like that, they keep on adding. No, like that, we are going to add in agile method. So first we have created the pod just now. Okay. Later point, we will go and add one more, one by one, one by one, one by one, so that finally you can come to know what is the BMW. Now it is nano. Okay, just we have started. We have a very, very basic thing. Going forward, we'll add one more, we'll add the feature one by one, one by one. What Ravi is telling, I'm giving my pod1.yaml, correct? In office or in organization, it will be not like random name like my pod, your pod, and all. It will be something like observability.yaml. Inside that observability, all the observability related things and all there. But for that, we have another concept called namespace that we will go. Okay, now we have created this, and inside this one, we used image, correct? Nginx image we used. Let me quickly use my image, dev pipeline / Ravi : v4. In v4, what is the content we given? If I'm correct, we given content like this part should work from container Docker file. Docker file word should be there. Okay. So now I given this. I'll run this pod one. Okay. How can we run? kubectl apply -f my pod. That one. See, apply and create both you can use here. Okay. Create in the sense first time when you are doing you can use create. Second time just you are doing instead of name here Ravi, or if you want Ravi one, or if you want something like that, if you are changing, then you can create, you can do apply as well, right? So
My pod
already is there. So my pod one. Okay, see here, you can first time when you are running this, you can create, you can use create. Second time when you are running apply, or first time itself you are running apply also, no problem. Okay, so now this pod has been created. Okay, Ravi - Docker hub, that is what I gave the name. Okay, now we will go and check what output it is giving. kubectl it pods So I'll go inside this part. So kubectl exec in the sense execute -it interaction mode. So then I'll give you I'll give a name. Okay. So space -- space /bin/bash. You have to give space here, but in Docker we will not give space, but here you have to give space. Okay. So now you are inside the Docker hub. I'll go with the call localhost :80. See, it should work with Docker file. I'll take more up. So what we did now, we installed Docker file, but the Docker file we downloaded from our repository, our registry. So whenever it is coming here, it will give it to scheduler. Scheduler will see, okay, this has been, I have to download from Docker Hub with registry dev pipeline. Inside that I have repository called Ravi. Inside that I have tag called v4 that I need to run. It will instruct and it will download and it will deploy it here. Okay. So that is the advantage of Docker Hub and keeping our container inside our repository. So each and every time you no need to go and edit this file. Wherever you want, you directly directly deploy here in the image. You give your all the information. It will download and it will deploy. Okay. Now we'll go with multi-container. Like in this one I have a Tomcat. Okay. Another one we will take Ravi, this one only. Yeah. VI multi. See this name and just I'm giving for your examination. You should not feel that for multi-container we have to use multi-con only. Pod we have to use pod only, like that and all. You should not use. What happened? VI command not found out. Oh, okay. I'm sitting inside the container. See here, I told no container is very lightweight. See this VI and all unwanted for container. If you want, you have to install. You have to install with external this one. So this is what the container. I told if you install in normal OS, it will take 5 GB space, but container will take only 195 MB something. It is there, correct? 195 MB something the size. How? In the sense, unwanted files and all, unwanted applications, it will not execute. Whatever related to whatever need for Nginx, only that will be deployed here. Okay. VI multi .ym. So okay, no problem. We'll take this one more container and we will deploy from that file only. Okay. So cat, what I have my what is that name? My pod1. My pod1. I will take cat pod1 YAML complete content. I'm going to send to my multi. So my I given a multi con dot YAML. So this redirection, what it will do, single redirection in Linux, it will erase whatever available inside that file, and it will copy this content and it will put it here. Okay. If this file is not available, then it will create new file and it will do this work. We'll check whether it is copied here or not. Yes, it is done. What we are going to do, we are going to declare multi-container, correct? So VI, I'm going to declare one more container. Escape 1, 2, 3, 4, 5. shape file yy. So here T. Okay. So what I did, I am going to create one more container. My second container name is my container 1. Okay, it's multi 1. Then same. I'm not using Ravi version 4. I'm going to use Nginx here. Okay. Port. I'm going to put something. Nginx also will use 80, correct? So okay. So multi container I'm going to use. I'm going to create. What is the command? kubectl create -f multi container.yaml. Okay, I gave names are same name. Okay, multi container already we created, correct? So I have to change this name. Multi 1, multi 2. What happened? W Docker Hub already exists. Okay, pod name also already exists. Okay, kubectl get pods. If you do so, here one is created, one is waiting. See, we'll wait, we'll see what is the problem. Okay, created. Okay, so one time it is restarted 5 seconds ago. So running. Okay, so if you see for this Ravi Docker, this is related to my multi container. See here, 2 pods it's need to create and 2 pods is running. Desired state and active state both are looks good. Now I can go into the container. I can search, for example, kubectl get pods. Okay. Crash loop back is coming. Wait. It is keep on restarting. I'll do one thing. I'll take Ubuntu because they need. By default, this also will use 80 port only. Nginx also will use 80 port only. So what I will do, I will take here some Ubuntu image. I don't want to and all. Let it take default port. If you declare, it will take port which you are giving. If you are not declare, then it will take default port which is suitable for you. Okay, now I will create get pods container creating. One is ready. Crash loop is coming on. 1 minute. Okay, running, both are running, both are doing. So if you want to see what was happening, why it was doing, so you can use kube describe command. So what it will do, kube describe command, what it will do, it will give you the background, what was happened. Do you mean describe? Okay. So you have to give in this way. So kubectl describe and which object you want to describe. Pod object. What is the name of the object? That's it. Okay. So if you see here, it will give you all the informations about more information about that while creation, what and all it happened. So it was giving this, assign this, it is assigned on this particular, what is it, the node, okay? Because we have two nodes, 155 and 178, something like that, correct? So this pod is assigned for this particular node, okay? This pod created there, what is the IP address, and many informations you have. Finally, in the bottom, you have logs as well, okay? In the logs, it will give you how it is. You see pulling image of Tomcat. After that, successfully pull image of Tomcat. So all this information it will give you. Okay. 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 Now kubectl get pods. Now I'll enter into this Ravi kubectl exec -it. Then pod name -docker /bin/dash docker. Hey, why today too much spelling mistake? Okay, so I enter into here. I enter into this one. Okay, so default container multi 2 out of 2 containers. Okay, what here we will do, we'll run the command call, and what is my localhost? I will run localhost :80. See, work with Docker. See, like that, inside the pod, you can deploy 2 different containers. See, same container, if you deploy for same application, you have to give the same port. That will not work. But different port, it will work. The problem is that is not advisable. Here I deploy in C1 Ravi container, and in C2 I deploy Tomcat. It is working fine. You can access it, but that is not suitable. But some pods inside, when you want back-to-back or supporting containers, sidecar containers and all there for collecting the logs. Okay, that will very helpful. So to that the container name is the container user is only to collect. In that case, you can deploy here, no problem. Why? Because whenever this is alive, this should alive. Whenever this is alive, this should alive. So if anyone goes down, another one also goes down. That is why we are telling this tightly coupled. These two are tightly coupled. So in that scenario, you can deploy your pods. You can deploy your container inside the pod. But see, you can deploy number of pods inside the worker node. Again, based on the resources. What is the resources? Memory, CPU, storage. These 3 resources are important. Based on these 3 resources, you can deploy n number of pods here. Until unless you have free resources, you can deploy pods here. Then why we need to worry about this? But that is possible. We are not going to do that. Okay, I have given all the informations here. Same like if you want to check any logs, also you can go with this command kubectl logs pod, then pod name. It will give you logs here. Whatever we have seen here, correct? These logs it will give you. Okay, do you have any doubt on these basic comments?
If anyone has a doubt, then let us know. Okay. Yes, no.
Okay. We'll move towards next. Next topic is namespace. Correct? namespace is nothing but we can say this is mini cluster. Actually, worker node 1, worker node 2, correct? This is coming under cluster. Correct? This is coming under cluster. I have 2 worker nodes. What I'm going to tell them, I'm going to create 2 different namespace here, which means one namespace I'm going to declare here for app, another one is for DB. So when you create namespace, no, in worker node, see in these worker nodes, pod is one of the object. Like that, you have many objects. If you see here, replication set, deployments, service, like that, many objects we have. Namespace also one of the object. Okay. So these objects will be isolated when you are creating namespace. For example, inside this namespace, you are running any part. Okay. That part, internally, these 2 parts will be communicated by using these IP addresses. But here, it will not communicate with this. Both are in node 1 only, even though it is isolated. That is the advantage it is given by namespace. Whatever resources you are creating here in this namespace, those resource directly cannot created, but internally, if you write codes for connecting, it will happen, but by default, it will not speak. This is separate, this is separate. Okay. Anyway, about this namespace, in upcoming sessions, we will do some practical sessions, but now we will just know how can we create a namespace. Okay. Now, I'll create. So by default, what happens? Whenever you are creating any pod, by default, it will go for default namespace. So kubectl get namespace. If you type namespace, it will give you all the namespaces. By default namespace is there. Kube node, kube public, kube system, like that. Totally 5 namespaces are there, which is created by. I'm sorry, it is 10 o'clock. It is crossed. If you are permitted,
you will bind up at 10:30.
Yes.
Is that fine for everyone?
If anyone have concern, let us know. No problem. We will continue tomorrow. But if you are a supporters, then it will be helpful.
Okay, go ahead.
Thank you. Thanks. Okay, so if you see here, we have namespace. By default, I have not created any namespace so far. By default, it is created. Whenever you are deploying anything, it will go and it will sit in default namespace alone. Okay, so to create namespace, kubectl. Okay, so let's see. Instead of namespace, you can give a NS also. kubectl get NS. Okay, namespace shortcut is NS. NS also you can give, same output it will give. Same like instead of pod, you can give PO, pods. Same like a node, you can give a NO. Correct? These are all shortcut. So I'm going to use NS only. Why? Because you should not get confused. That is why I told. So kubectl create. What I'm going to create? If I want to create pod, just by command also you can create pod. We are using YAML file. Why? Because command no one is using in YAML file we are using, and we are using those YAML file for Terraform, all those things. And we in our session today or tomorrow we are going to take Helm when we are doing auto. Okay, during that time we are using YAML only. That is why we are using YAML. So kubectl create. After that you have to give the object name. Which object you are going to create? I'm going to create namespace object. what is the name you need? Say, for example, I need dev namespace created. Now I'll go and check what is the namespace. See, dev namespace has been created. Okay. Now kubectl get pods. See, when I give -a in the end, when I give -a, it will show me. If you don't give -a, no, it will show you only the containers which is created inside your default namespace. It will give the information about only default namespace. If you give -a, it will give the information, or it will give the pods information where it created in all other pods. Okay. If you see here, Ravi, these things created by us, all three has been created in default namespace. Cube system created something, these containers. Who created this? This is created by cluster, EKS cluster. Why it is created? It want to communicate. It want to do deploy. It want to speak. It want to get the replay. So for that, it is created by its own. We no need to do anything. Even though if you create here, or if you create on servers, physical servers, AKS, if you create on AKS, some extra nodes for AKS will be there. But this kube proxy, these and all common. Metric server. Do you know what is metric server? Metric server is nothing but if you are coming from observability platform, what metric server will do? Metric servers will keep on give you the information about your nodes, pods, and cluster. What is the information? Status.
It's like metric browser.
Sorry?
So basically, I'll tell you how the metric server work is. Now, what you have to do is you have to suppose your Prometheus is running on the same server, okay? Then it will, because Prometheus is running, so it will collect all the information from the metric server because that has all the data, okay? And then it will expose, you can expose to Grafana or whatever you want to do this, right? So that is the reason by default when you create a cluster with normal from the GUI, from the AWS console UI, it will ask you, you want to add a Prometheus server, you wanted to add Grafana, a lot of things you can add on so that it will interconnect all those things and you can expose the data in Grafana because that is the reason we use metric server. Go ahead. If you have any doubt, let me know. Any questions?
Like for monitoring purpose, like monitoring tools.
Yeah. So basically, when you use any, suppose you want to monitor cluster, right? What is the cluster status, whether your node is working, whether node has sufficient memory, sufficient CPU, sufficient memory, right? Node is nothing but just like a virtual VM, right? It's a normal VM, EC2 container, EC2 VM, right? So that everything is working or as expected or not, right? So we need to monitor that. So you can monitor via Dynatrace, you can monitor via Datadog, you can monitor via open source platform. All those things you can do that, right? So for that, we have something called metric server. So it will metric server will expose all the data, okay, all the metric information related to the cluster, and then Prometheus server internally speak, okay, not like it will, because Prometheus is also running on the same server. Now suppose you install Dynatrace 1 agent. So Dynatrace 1 agent, it will install on the master, I will install as an operator and send the data to, and it by default will get installed Dynatrace 1 agent on your worker node, and that worker node, it will take the data internally from metric server. Clear?
Yeah.
Got it.
See, these are the Kubernetes cluster, correct? Master node and this one. So what normally you will do, say for example, you are using Dynatrace or Prometheus. So here it will be agent or receiver, something it will be there. So it will be installed here, the agents. And here, whatever metric server I shown, correct, the pod, those pod will give all the information, the metrics to here. From here to, you will have outside Prometheus. So this is Prometheus. From Prometheus, what you can do? you can send to time-based database.
Time series data, time series database.
Time series database. From time series database to what you can use? You can use Grafana or you can use some other tool to view the database. So that is the metric server pods work. It will work on all the servers. It will create all the servers. Okay. But that will when you are learn about observability, during that time they will explain you how the communication is happened between Prometheus and this worker node and master node. But who will responsible to provide metrics? These containers. Who created this containers? It is created by master itself. If you see here, for 186 server, one metric container is there. For 155 node, one metric container is there. Correct? So two metric servers. One is for node worker node 1 is for worker node 2. Anyway, this metric server is not under our this one discussion. Just I gave you the example. Okay, we have now namespace called dev. Okay, what I'm going to do, I'm going to create one pod again. Okay, see, I'm going to create kubectl, create or apply, sorry, create only. So create my pod, first pod I will use. Okay, my pod.yaml. What it will say? It will give me the error. So it is already there. Correct? Expected argument hyphen f I need to use because this file format. Correct? So what it is telling? It is already exists. Now, whenever you are running this command, it will go and try to deploy this pod on default namespace. Correct? Now I'm telling, boss, I have my own namespace now. Please go and create there. For that, what you need to add in the last, you need to add -n. -n in the sense nothing but namespace. Okay? -n, then give dev. What is telling? Created. Where it is created? It is created inside the dev. Okay. Now, how can I check whether it is created or not? So normally, to check the containers which is there inside the default namespace, what will use? Get pods. If you tell, it will give you the information of default pod. But I want the information about dev. What is there inside the dev namespace? For that, you have to add -m. Whatever you are command running in the command, in the last you have to mention -m dev. So it is telling that in the dev, review one container is running. So these both are isolated. This is different namespace. This is different namespace. That is what I said. Namespace is nothing but it is a mini Kubernetes cluster. It is mini cluster, isolated virtual cluster. I could say. Okay, virtual cluster. I could say. Okay. And you may ask that how can we log in into this? If I log in kubectl exec exec -it. What is my pod? Ravi. Okay. Then /bin/bash. Correct? It will go to this pod actually. By default, it will take default only. If you want to go here, then you have to add -n dev. This okay. You need to add here some. See here, you have to give -n dev. So you are telling that you go to this pod, but this pod should be located inside the dev. Correct? So this is completely isolated. The same pod, if I run, what it will say? It will say that already port 80 it's using the pod, you cannot create here. Something it will give an error, correct? Same this one. But here, due to we created different namespace, the same pod with same port, you can deploy here as well as here as well. By default, whatever you are creating, whatever object you are creating, that will go and sit inside the default. It will not go any other namespace. Anyway, we are going to discuss more about namespace so that you will come to know. So these are the basic commands: get namespace, create namespace. Then while you are creating, you have to give them namespace. Okay, while you are getting the pod. Same like for DB. If you want to search for all the namespace, then you can go -all -namespace. Or in one command, this is nothing but this capital letter A is equivalent to this. Next, we'll go with labels. Labels and selectors is very much important. Why we need labels? Labels is nothing but you have bunch of parts here, correct? See, as I said, we are going in agile method. First, there is a car with tires and engine, and it will running fine. Later, we will add one by one. Finally, we will make that car as a very high secure car like BMW, Audi, something like that, correct? So now we are going to add one more concept here. Namespace we added, we came to know, correct? The isolated parts. And second, what we are going to learn? We are going to learn about labels. So each and every parts we can give labels so that whenever we are filtering, whenever we are running any commands, we can filter those parts and we'll execute that command. It is simple. Okay. So I'll give you the example of labels. So here we have API version, pod, metadata. I told you inside the metadata, not only name, we are going to create labels as well. Correct? Inside the label, here I'm going to give two labels. One is environment. Why we need this much lengthy name environment? We'll give short name environment. Correct? Okay. So here what is there? Okay, here environment is itself there. Leave it. Okay, environment, production, app, Nginx. Here we have containers. Inside the specification, we declare containers as usual, what we have done so far. Okay. Now what I will do, I will create this part. Okay, inside the dev container, and we will see. So VI.
Can you please once again explain the importance of these labels?
Okay. See, we inside the worker nodes, we are deploying multiple pods, correct? So to filter these pods, I want to select only pod 1 of node 1 and pod 2 of node 2. If I want to select only these two, or here I have multiple pods, in that I want to select only dev environment pods or QA environment pods. Okay, like if you want to select specific pods, or you want to select only pods where Nginx is running, or you want to select pods only where Tomcat is running. So if you want to filter out these pods, because inside the node you can deploy pods anywhere. This directly will take care by your controller, correct? As Ravi said. But after deployment, you can filter the pods based on the labels.
So basically, labels are here just like a key value pair, like which we define a tag, right? env dev application this, version this, right? Service name is this, okay? So that it will help you to identify, because when you deploy the application, right? In the production environment, you can see at least 40-50 pods, right? Service are running on the one cluster, because cluster, if you are running as a cluster, right, you will not have multiple cluster or something. You'll have a one cluster and multiple worker node. Okay, so you'll have a multiple services running. When you have multiple services running, you'll have multiple pods, right? And definitely each service is running inside the namespace, right? But when you do kubectl get pod, you will get all the pods whichever the namespace we have. Okay, so now you need to understand, okay, right? This pod belongs to which application, which service, right? Which environment, which version, so that you can understand that and you can go inside that and you can do the changes accordingly.
So these like labels, can we use them while running our commands also?
Yes.
Yes.
Okay.
That is the main agenda.
Got it.
So now you want to go inside the application and which has a 2-3 environment, that a specific environment you want to go. And now name is looks like similar. You cannot understand, right? Suppose I joined
Yeah.
organization, for you it is very difficult, right? Now you have implemented, you develop, so you would be knowing that. When I joined. For me, it will be everything. I should go and check that, right? So if the label is there, I can understand. No? This service will belongs to this application,
Right.
this environment, this version, all those things, so that you can easily go and then you check that, go inside the container, check that what is happening, check the logs, all those things. You can check that and you can do whatever changes you wanted to do. You can perform that, right? So for you to do the performance engineering, right? If something goes down for you, for then it will be easier. Okay, like for anyone, suppose, see, as a layman, anyone log in, right? They can able to understand this service belongs to which environment, which application, which version, all those things. And so that is nothing but just like a tag which has a key value there.
Got it.
Okay. Okay. Now see here, I have two YAML file has been, I created two YAML file. So one is label demo and production environment label what I given. Production label I attached for this pod. Okay. And app Nginx, these two labels I attached for this pod. Okay. Rest of the things are same as what we have seen so far. And second, same pod name I given. Let me change this pod name, label 1, something like that. Okay. So label 1, here I given in dev, environment as dev, and app is Tomcat, and container also different. I'm running these both. kubectl create -f lab.yaml. I want to create this on dev. We can create and create on default also, but just to show you, I'll create on dev. So lab and lab on both I'm going to create on dev itself. Okay. Now kubectl get pods -n dev. See here, label demo, label 1 demo. Both the parts has been created. Okay. So what now I'm going to do? I'm going to select. If you give a card, then you don't know, correct, what is running here. If you are new the environment, your manager is telling, hey, select the pod where label equal to Nginx. Select it and let me know whether it is running or not. What you will do? You will open this YAML file and you will check. Otherwise, you will go and open this containers and you will check. No, that is quite difficult. So that is why we could use kubectl get pods -n dev -l. L is nothing but label environment is equal to nginx dev. If I select, see here, only one. Before, how many pods it was showing? It was showing 3 pods. Now it will show only label 1 demo. Why? Because if you see here, this is label, correct? Label 1 demo. Label 1 demo. Lab 1.yaml. If I see here, what I've given here, environment is dev. So instead of listing all the pods, till now it will list all the pods. After that, one filter we will put. Okay. So wherever environment is dev, then it will select. See, this is not only for list. Even though if you want to delete part, normally how you will delete? Two ways are there. We can delete kubectl, delete -f, and whatever the pod YAML file is there, no, you can give that YAML file lab1.yaml -n dev. This -n dev, each and every time you have to give, otherwise it will go and do the whatever command, it will go and execute on default this one. Okay, so -n dev you have to give. This is the one method. If you delete, it will go off. Okay, let me delete and show you. See, deleted lab1. Now again I will create. Okay, now I'm going to use another method by using the pod. Okay, so this is to see the pod. Now what I'm going to tell, I'm going to tell them that delete pod. Delete pod name I need to give a delete pods. What's pod name? Okay, I'm not giving anything. I'm telling delete pods wherever this particular label is available. See here, it is automatically deleted. So in your environment, inside your namespace or inside your worker node, say for example, one dev node, many nodes are there, dev nodes. Okay, your manager is telling no, we don't want dev node. That is we just created for testing purpose. Delete the dev nodes wherever it is available. How it is possible? So whenever there will be instruction, whenever you are creating any pod, if it is belongs to dev, give the label dev. While creating itself, they have to give. If they don't give, that's it. We cannot do anything. We cannot use that utilization and we cannot use that feature. Okay. But whenever they have, whenever they are creating, during that time, they have to give that. Okay. Whenever they are creating, they have to give that label so that we can list, we can delete, or we can create whatever we want, we can do accordingly. So label is nothing but only to filter out your containers, or sorry, not container. You should not tell container at all. Pod only. Container inside the pod only, container will be there. Okay. Leave about container. Whenever you are speaking here in Kubernetes, you should speak as a pod. So this label also apply on pod only. It will not apply on containers. Okay. This label will deploy on apply on pod as well as node. Also node we will see next pod. Okay. It will not create for container. Label will not attach for container, only for pods. So you select or filter out the pod on this worker node. Why? Because inside the worker nodes, some worker nodes and all hundreds of thousands of pods also will be there. Okay, how will you filter? Say for example, wherever you have one update in Nginx, you have an update. That too only you want to do in dev pods. The other pods you don't want to do. Okay, but some this one some organization, they will use different cluster itself for dev, like different cluster, and for production like different cluster like that. But what I'm saying, in small organization, all the pods inside that you want to update the Nginx, that too only on dev pods. How you will do that? You are writing YAML file. So by using this label, you can filter out. Okay, I want to do my changes only on these pods alone. That is the advantage of pods. Sorry, labels.
So basically here, when any organization, even we are using, right, Kubernetes cluster for applications, so all the non-prod, okay, non-prod means like a dev, QA, UAT, UAT, till UAT, we have everything running on one cluster, okay. And there is a concept is label, which mentioned, and there is a concept of tent also, okay, that he will be explaining little later. But we can use tent as suppose you are creating a worker node, right? Suppose we have a 2 worker nodes. So we have some same way we used to create something like 5, 6, 7 worker node, and that has this 2 worker node for dev, this 2 worker node for staging, this 2 worker node for QA, something like that. So that tent will assign, okay, which resource I have to worker node I have to use. Okay, those kind of things he will explain in the later tomorrow class. But labels and it will be helpful when your development, either dev, QA, some environment, UAT environment, it will be running on same cluster. Okay.
Yeah. See, these labels, all those things are small features. By using that, we could shine our infrastructure. That's it. This is small things. Without label also you can do, but quite hard. Without labels, can I run cluster? Yes, you can run cluster. Your application also working fine, but it will help you to filter out the parts among a number of parts. Okay, it's 10:30. Tomorrow I will continue, Ravi.
Yeah, sure.
Is it okay? Because I
Yeah,
don't
yeah.
want to get them in this one. Some people will have some other comments today, Saturday. Okay, so tomorrow we will discuss about selectors, and we have node selector also. I'll finish my one in 2 minutes. Okay, 3 minutes. 10:30 will out. So node selector. Tomorrow we'll have node selectors and selectors. What is the node selector? So whenever you are deploying any pod, how can you tell your Kubernetes that I want to deploy my pod only on node 1 only? I don't want node 2. Like, how can you select? How can you tell them? That is what the node selector. That is what I said, correct? We will go one by one features. We will keep on add. Finally, we will do all the deployments. When we will do final deployments, you will clear about all those things. Okay. So after going into the main picture, scaling and replication, for that we are going to use replica set and deployments. What is deployments? After that, networking. This networking concept is very much important. If networking concept, if you are clear, then Kubernetes you can you can play like anything. Okay, so network concept I'll explain you very clearly. So how can we communicate pod to pod, node to node, and from outside, all those things. Okay, so we have cluster IPs, node port. Finally, we have to finish with Ingress today. Okay, this is lagging due to some my network issue, something that storage, sorry, some communication issue. Okay, so we'll start with till Ingress. After this Ingress, what we'll do, we'll directly go end-to-end deployments with CI/CD. CI, we are going to use GitHub Actions. For CD, we are going to use Argo CD. So whenever you do any changes in Ingress, any changes here, automatically those changes will deploy automatically. You no need to create pod, you no need to create namespace, you no need to create anything. Automatically it will taken care by your CI/CD pipelines. That is what the complete agenda of this course. Okay, so tomorrow we'll connect and we'll continue this session.
Thank you, everyone. So any questions over here?
No questions. Thank you very much.
And tomorrow that session may get extended for 4 hours to 5 hours. Okay, yeah, 5.5 hours, because there is a lot of topics. Because when Argo CD has a lot of things, when you do the deployment to rollback, all those things, and even Kubernetes has a lot of features. Okay, so it will get extended.
Yeah, but I will try to finish it by 10 o'clock. But if it extend, it may extend half an hour.
No, it will get extended for ensure, because a lot of people have a question dot. So we can manage till 11. Okay, is that fine for everyone?
Yeah.
We can start the session little early. What do you suggest?
But
Everyone.
don't miss tomorrow's session. Tomorrow it will be more interested. Why? Because we are going to do end-to-end deployment. So whatever you have doubts here, I know some doubts you will be have how this is working, how that is working. All those doubts automatically it will clear by tomorrow.
So basically, yeah, go ahead.
Yeah, I mean, just a session. Probably you can start earlier.
Yeah,
If
So
it's
that's what.
okay for you.
So better we can start at 5 instead of 6. What do you suggest,
Ravi,
everyone? Eva?
Ravi, I can't join because it's already 5:30 morning for me.
Okay,
So
then we'll start at 6 only, and we'll
yeah,
close little late. Okay.
5 will be too early for me. Yeah.
Okay, fine. Not an issue. Okay. Okay, everyone.
Okay.
If-
Thank you.
Thank
Thank
you.
you. Thanks, so.